Good morning, everyone. Welcome to our Terminology Server pre-hack Learnathon. This is our first Learnathon. My name is Helen Young. I'm the Communications and Engagement Lead for INTEROPen. INTEROPen, as you're probably aware because you're here, is a community or a network of people who would like to help accelerate the adoption of interoperability standards across health and social care, primarily in the UK, but not limited to England and 4 nations. We're going quite international today, and we have a great team here from Untitled Server and eHealth Research in Australia. So they're all in the sunshine and it's late in the evening while we're in the snow in some parts of the country and in lockdown. So we're 2 different worlds at the moment. Really good for everyone to join us today. Just a few points before we start. People are still entering, so if you excuse me, I'm just sort of letting people in at the same time. But we're here really just to lay the foundations for our Terminology Server hackathon. Now, the hackathon is taking place on the 24th and 25th of February. So if you have a team who you would like to join that, I'll be sharing the link for that event as well. And it's really a morning focused on learning. So the team are going to go through, the vision for the Terminology Server, what they see as its role, how it can support various areas. But INTEROPen, from the INTEROPen perspective, we're here to support it because we think that this is something that could support interoperability. And we're really keen to get people involved in our hackathons. Our hackathons we've had about 7 now, and we have about 200 participants, often between 100 and 200 participants. INTEROPen is all about openness and transparency, and we use a collaboration platform called River to share recordings of our hackathons, the output of our hackathons, progress on our hackathons, and we also have monthly get-togethers for the different hackathon themes, which is a new thing which is starting. So to really make the most of this event and future hackathons and to get more involved, you should really join INTEROPen. No pressure, but that way you can join the collaboration forum and get full access to those contacts, that network, those resources, etc. To join, I'll post some links in the chat, but it's just go to our website essentially, and here we go. You just go to interopen.org/join, and you should then receive in a couple of days a message inviting you to join River. But for now, I will pass you over to Nicholas Oughtibridge, who is here, who's going to introduce. Oh, Kate, are you going first, Kate? Okay. So Kate, and we'll kick off. Okay, thanks, Kate. Over to you.
Hi everyone, we thought we might just do a quick Mentimeter exercise to find out a bit more about who's actually on the session today and what you're hoping to get out of it. So hi everyone, great to see all your faces. My name is Kate Ebrill. I work within the Australian eHealth Research Centre, which is part of CSIRO, which is Australia's National Science Agency. And we're very pleased that Untitled Server, our Fire Native Terminology Server, has been chosen by the NHS to be the National Terminology Service. So we're really pleased to be supporting this session today. So just to get a bit of a feel around who's on the call, given we can't all be in person, if you on your device you're using or going to another device, go to www.menti.com, and there is a code on the screen, 3965671. Just a great way to find out, are you a clinician? Are you a researcher, developer? I know there's a few SNOMED geeks on the call. Pretty sure there's a few fire geeks there as well. Are you a CIO or a CCIO? Just so we can get a feel for who's joining us today. Great to see a good mix of people. I don't think everyone's actually responded yet, but we've got a really great mix of people joining today. And this, normally I know hackathon events or Fire Connectathon events are very much developer focused. For this event, we did want to make it more of a learnathon so that everyone could understand whether you're a developer or whether you are in more of a research or project position without actually having to have developer skills today. So this is a really great intro session. Some people have asked where to find. If you go to that menti.com and use that code, it should allow you to put your response in. We might jump to the next question. So I think we've had about half of the group who've responded to this question and a good mix of people. So if we jump to the next one, Dion. I know my screen hasn't moved. Is it me?
It's you.
There you go.
Mine's still on. Who's in the room as well?
Mine's definitely updating, but then obviously I'm the one presenting. Can other people who are seeing what I'm presenting see it change?
No, still on.
It hasn't changed for me.
Hasn't changed for me either.
I've had the second question.
I've had the second question on Menti, but you're still presenting who's who in the room for me on.
Interesting. Okay,
I've not had this happen before.
I'll stop the sharing and start the sharing again, see if that helps. Can you now see the other question on the presentation, or?
Nope, it's all black.
Just a black screen for me.
Huh.
Just get a message saying that you're sharing.
Yeah, I started sharing.
It says I'm sending my screen.
We probably shouldn't waste time if we're having tech issues. We can jump straight into the session, which is a bit of a shame. We've never had problems with Menti before, but we won't waste time. But I will.
Menti is updating, Katie, so you could still just use Menti and give us the answers.
There you go, Dion. If you can see it.
Yeah, the other thing I can do is try to share that window, if that helps.
No, your screen's not sharing, mate.
Interesting. Okay, well, I will advance the Menti thing. I'll tell you that it's predominantly fire starters, 17 fire starters, 15 catching fire, 5 on fire, and 6 firebugs. So
I probably can count who those firebugs. I can probably point them all out on the call. And the final question then, if everyone else can still see Menti, I myself haven't logged in, then the objectives for today's session. So if you want to advance to that one then, Dion, if everyone else can still see it, but just not on your screen.
Yes, I've advanced to that.
Oh, there you go. Now it's back.
Oh, right. So you can see that now.
Yes.
Yeah.
Wow. I literally didn't change anything. So, yeah, strange.
I'm always glad when we put up this Menti question and everyone does confirm that what they want to hear is actually what the agenda is about. It's always my worst fear that we're going to get a bunch of objectives that relate to absolutely nothing that's been prepared. So I'm very glad to see that. I do support the person who wants coffee, except now at the end of my day, I've got a completely other different beverage with an objective for that in mind than a coffee right now. Okay, so I think what's good to know is that the session is very much aimed at people who are wanting to learn around fine terminology services and understand more around the national service. I know Michael, when he does follow the yellow brick code, will take it easy on you all. Please also, this is a chance for this session to be really interactive, so don't hold back. We do have a little bit of time for questions as we go through the sessions this morning, but certainly in the 3 breakout groups, the aim in those 3 breakout sessions is that they're to be really interactive. There's some let's build exercises, some walkthrough exercises, but that's your chance to ask as many questions of the experts in the room. And so please don't hold back. The more questions, the more that everyone will get out of the event. So Nicholas, if I throw to you to talk about your vision around why you wanted to set up the framework and set up the National Terminology Server.
Yeah, thanks, Kate. And thank you, Helen, for pulling this together along with your colleagues in INTEROPen. It's really kind of you all. I think actually we've had a good illustration of this in that the first question had some classifications, and I don't know if everyone in the room felt entirely natural with the classification choice they chose. And then at the last one, we ended up with a whole load of vocabularies, and some of those things you might say were just synonyms of the same idea, and other ones were quite complex. When I started off in the health IT business quite a long time ago, it was quite easy because the first letter of a code told you its broad category, and then as you got further and further down the code, you got more and more detail into it, and it was a nice, easy way of classifying health data, and it allowed us to do things like morbidity indices and age sex registers and all those basic things that were really quite empowering at that stage. And then, of course, people thought, well, we ought to do something with terminology, and terminology is really good because it's close to what the language the clinicians would want to use, and as such, therefore, is much more clinically relevant and more like a case note record might have been when it was just put into a Lloyd George envelope or whatever it was. Nowadays, we have a very different set of systems. We've got really quite a plethora of different ways of classifying data, of coding data, of quickly getting data entered into computer systems. And the reality is now that a good, well-designed, terminology-driven interface will be quicker for a clinician than using a paper record. The prevalence of those high-quality user interfaces isn't where the market needs to be, but I'm sure that will come. So how do you end up enabling the marketplace to go and bring those? Well, one of the ways is to make all of the complexities of terminology that little bit easier. And the terminology server is one of those things you can do it. And the agenda today sort of goes through that quite well, starting off with the basic how do you get data in with the terminology servers, look ahead and sorting and capabilities in there. But it goes a stage further and takes it through to all the analytics that can be done. And I don't know to what extent there's a hierarchy between fire geeks and catching fire and on fire and all the rest of it, but there's maybe an order there of some form and some form of way of doing things. But when you get into clinical data, it really does matter. And the opportunities for getting things right are really important, but also the dangers of getting things wrong are quite important. You know, it'd be quite easy to get a cohort selection for a new treatment, vaccination against a new viral infection, for example, and to get your cohort incorrect because you didn't understand your terminology correctly or you didn't understand your classifications. And so what we have in the terminology server is a way of commoditizing the complexity of using codes, vocabularies, so that they can be used at the desktop by the person who needs to use them without the complexity getting in the way of getting things done. So I've got a slide I'll aim to share. If this goes horribly wrong, I'll just talk to it. So hopefully that's coming across. Setting out the terminology server, we're really trying to hit the full spectrum of healthcare uses, from the delivery of care right through to the life sciences and research. And I think actually the work that's gone on in research has been dramatic within the last 12 months within this country. But just in the delivery of care, that getting data into care records so that they can be analysed, so that they can be compared, so that they can be shared between computer systems and still allow the computer systems to play with each other and to actually add value by providing some computing power rather than just being a glorified fax machine or an electronic filing cabinet. We then get into the whole of the commissioning and funding arrangements, and at the moment that's dominantly driven by some classifications that have been around for decades, but that will end up being enabled to be moving to much closer to the care record in due course. Commissioning and funding always ends up following the delivery of care rather than the other way around. The danger is, of course, that you end up with the commissioning driving the delivery of care in ways that you don't want it to happen. So,
Nicholas, sorry to interrupt. You're not sharing the slide. We're not seeing the slide here.
Okay. Has that worked?
Yeah. There we go. We've got the vision now.
So, moving on from that then, working on cohorts, really critical that we can identify cohorts of patients, and in particular that we can target treatments or investigations at the right people. And that's becoming so much clearer since we set out on this journey. But it was an aim right at the beginning of the journey to set up this framework contract. And then finally, into the research space, complex analysis across multiple coding schemes, across data from completely diverse clinical systems, and from the clinical trial systems and the genomic systems, bring those all together so that we can do complex analysis. And it's a pity that Michael from Genomics England wasn't able to join us today, but he's done some excellent work using the terminology server in that field. So that's really all I wanted to share with you. Thank you all to joining it. I hope you have a good time. And I will be staying with you for the full journey. So if you've got any questions, just send me a message in the chat and I'll do my utmost to go and reply to you. And now I shall hand over to Kate.
So I think Dion's going to share the slides, and Dion and I will do a double act for the next session and just give some background and an overview of the actual solution that we're putting in place with NHS Digital and DXC, and some overview of the use cases and what Onto Server is all about. So next slide, thanks Dion. We've already done that bit. Just to explain a little bit about the team. So as I mentioned earlier, I'm from the Australian eHealth Research Centre, and we're part of CSIRO, which is Australia's National Science Agency. And we've been delivering terminology solutions to governments for a number of years. Onto Server, which we'll talk about a lot more tonight, has been at the core of the Australian National Clinical Terminology Service for the last 4 years. And we've been working with NHS Digital and NHS Wales Information Service as part of a proof of concept project over the last couple of years. In order to deliver Onto Server into NHS Digital as part of the framework and to truly deliver a solution, we're partnering with DXC, who's leading the work around the implementation partner and the managed service provider, and brings all of the expertise in cloud hosting and service delivery and support, and jointly we're working together. I know that Dougal and Andy and probably others from the DXC team are on the call tonight. So feel free to ask questions of those guys in the chat, and I'm sure they'll chip in if they've got anything to add as well. Next slide, thanks, Dion. And the goal really around standing up the National Terminology Server, and this is something that Dion, who's going to talk next, also will refer to, is that Dion and I both were responsible for standing up the National Clinical Terminology Service in the Australian Digital Health Agency that 5 years ago when we started our journey. And we had a very similar goal then to Nicholas's goal now within the NHS. And how do we actually simplify the use of clinical terminology classifications and other code systems by addressing those key challenges faced by implementers? We all understand the benefits, and the benefits are many when it comes to interoperability, research, analytics, but we also understand there's challenges and there is a cost to implementation. So how can we actually support that and encourage vendors and healthcare organisations, researchers, to be able to better adopt those terminology products and coding products within their solutions, within their organisations, and do that in a way that can truly achieve the benefit? And establish that one-stop shop where you can actually get access to all of those national specifications and code systems through that one standard API. And importantly, not just be about a national solution, but how do you create an ecosystem and enable enterprises to create their own one-stop shop locally as well? Importantly, how through that ecosystem can you improve collaboration between both those producers and consumers of terminology products and services, and create that true community approach where content absolutely and national code systems can be delivered nationally, but also made available across regions, across organisations, across trusts who also want to develop, create and share their own content, leveraging the national and extending on the national. And the end goal around all this is really enabling that realization of benefits. We're all about seamless interoperability. I mean, that's obviously caught it INTEROPen, and for a number of the members of this group, this is what you're about, is interoperability. But also importantly, the whole point around exchanging data, making it interoperable, is at the end of the day also improving reporting and advanced analytics as well. Next slide, thanks, Dion. There are a number of common use cases that the Terminology Server can support. Fundamentally, at its core is absolutely around maintenance and distribution of terminology. One thing to point out that what is different is this is not a terminology server that's about authoring. This is a terminology server that's about runtime distribution, runtime implementation. So it has authoring capability, but it's really about implementation and supporting implementers. So the key use cases, and certainly we've seen this with a number of our implementers, both within Australia and globally, is how do I make that national content readily available via FHIR APIs and a syndication service? And Michael will talk a lot more around the FHIR APIs themselves when we get to his Follow the Yellow Brick Code session, and Dion will talk about the syndication service and its role further. Also about maintaining and authoring code systems, value sets and concept maps. And this is both at a national level and at a local level. And key to this is also, if you're a downstream organisation, being able to readily keep up to date with national code systems and maintain content locally. Being able to collaborate with the National Service and other healthcare organisations to develop and publish content, and being able to readily adopt things like SNOMED CT, which, you know, taking that complexity away of having to understand RF2, but being able to syndicate, update and keep up to date with those national releases, and particularly as those national releases become more frequent to support interoperability needs. Another key feature of the terminology service that it supports is around smart data entry and performant runtime use. And so being able to support and have those APIs work within clinical applications and be performant enough to support that, and support advanced use of SNOMED CT. And we're really pleased that Tracey is going to deliver a presentation on behalf of NHS Wales Information Service around how they're using the terminology server for runtime use. Key to this is also, and this is something that's core to INTEROPen and the work around interoperability, is information modeling and spec development, being able to bind terminology and value sets to data model and specifications, being able to validate the terminology content against those specifications, and also validate FHIR resources. And I know that there's probably a number of you on the call tonight where interoperability or modeling and spec development is core to your business. Interoperability and secure messaging, being able to actually validate and translate that content as part of a part of electronic health record or as part of integration, and validating FHIR profiles. And I know Richard Kavanagh is going to talk more around his use of FHIR terminology services in supporting interoperability. And I know he presented at a recent INTEROPen hackathon as well. So I'm sure Richard's got some lessons to share. And finally, analytics. One of the key use cases around being able to support advanced use of analytics. And Charles Guttridge from Barts is very kindly going to deliver a presentation later, and our breakout group will be supported by John Grimes and Kylie from our team as well. So I think that's the important kind of thing to cover, is that these use cases do cover various aspects, all the way from maintenance of terminology content through to actual runtime use of terminology content. Next slide, thanks, Dion. There are a number of benefits both at the clinical healthcare organisation and developer level. I think what we're finding with implementations of vendor products is around that ability for better UI and improved implementation of terminology. We know that part of the challenge, and I know Charles could speak to this greatly, part of the challenge around getting clinicians engaged with using controlled terminologies and things like SNOMED CT is largely to do with the user interface. And so being able to support good, performant, fast search within the products can certainly create that better clinical experience, and having the tooling and the APIs to support that, so that vendors don't have to actually understand SNOMED and can take that complexity of SNOMED away and actually just know how to interact with APIs, can make a massive difference. It can also support an ability through the tooling to get clinicians much more engaged in actually the development of the value sets and code systems themselves. And Charles is a great example of that. And he'll be walking through ECL, expression constraint language, in his session later. And I think when you can provide the tools at the hands of clinicians to get them more actively involved, can certainly make a better product at the end of the day. From a vendor developer point of view, we've certainly seen that it lowers the entry bar around much more faster and meaningful adoption of SNOMED. And a lot of the feedback we've had over our last 5-year journey with the National Clinical Terminology Service in Australia is it certainly enabled vendors to put the development effort into the cool, more interesting features of their product, rather than having to spend development effort on understanding how to deal with something like the RF2 release of SNOMED and deal with those updates, and can definitely support that much more frequent content update and reduce that duplication of effort by the industry. And part of that kind of discovering what other content is available, and that certainly is the same with healthcare organisations and research institutes, is the ability of this kind of solution where definitely a service being provided nationally, but the ability to then also at your local, within your vendor organisation, within your healthcare organisation, have local autonomy and governance over terminology management, and be able to syndicate content from the national service, and being able to participate in an ecosystem with other users of the national terminology and code system content and be able to collaborate as part of that. I think Nicholas's vision of not just having something that's available nationally, but being able to truly support the ecosystem, enable discovery of other content across the ecosystem and sharing of that, and really reduce the duplication of effort in the development of those value sets and those maps, but also improve the quality, because as you can collaborate in the development and share, you can start to improve the quality of the content that's out there as well. Thanks, Dion.
Just one more comment, if I can, Kate, because I noticed we've got so many developers on the call, which is great. I think from my perspective as a developer, when we were doing this sort of idea for Australia, was this idea of being able to provide all the terminology that was needed through one API. And we picked on the FHIR API as being a standard terminology services API, but I think that's a really powerful idea because certainly in Australia, terminologies came in all sorts of weird and wonderful formats, all sorts of different places, and it made it really difficult for developers because they're having to learn all these things. Plus, you know, there's updates, so you end up with things like RF2 itself in SNOMED CT potentially changing, or part of the technical specifications changing. So we wanted to provide a nice stable API to be able to get at what people needed and get at all of that content. So hopefully that's useful to a lot of developers. We certainly have found it so far.
I was going to hand over to you anyway, Dion.
Yes, cool. So I'll talk about a little bit about OntoServer and the overall solution. I won't go into too much detail in any of this, just in the interest of time. But if anybody wants to know any more, hit me up later. That's fine. So the overall solution for NHS Digital and for the framework actually involves a number of components. So OntoServer is probably the main component and the one that people are probably most familiar with. It's the terminology server itself, and certainly has a very broad implementation of 5 terminology services and very deep support for things like SNOMED CT, and the syndication is probably its key feature to be able to easily pull content into your server, and we'll go into that in a bit more later. So then there's sort of 2 flavors of Snapper, Snapper Author and Snapper Map. So Snapper Author is the main product available underneath the NHS solution, and it's a FHIR terminology resource authoring tool. So value sets, concept maps, and code systems. That's what it's there for. OntoCloak is an authorization server, which is actually sort of additional features wrapped over the top of and configuration on top of a product called KeyCloak, which is an open source authorization server, and that's designed for being able to control access to OntoServer while only configuring authorization there, and ideally delegating out identity management out to some other service, and then dealing just with authorization there, making it easy to sort of throw different authorization services in front of OntoServer. Atomio is a syndication server, and I'll go into some detail later in another diagram, but it's for managing sort of static content, if you think like releases of content, to be able to have a sort of secure static versions of released content, if there's probably its major use case. Shrimp is a browsing tool, which hopefully people are familiar with for browsing. SNOMED CT is where it originally came from, web-based tool, but it will also do LOINC and other FHIR code systems as well, and it's freely available, and you can point it, just like you can point Snapper at any OntoServer instance, you can do the same thing with Shrimp. And then there's a series of FHIR terminology transforms, open source transforms we've built over time, things like OWL and CLAML support, but then more recently some of the specific formats for the NHS. So narrowing in on just on OntoServer, which is probably the most important or the most interesting piece. So OntoServer was really designed to be a turnkey solution, so a solution that was very easy to stand up, turn on. It's delivered as a Docker image and requires very limited maintenance and you know, changes to monitor it and control it. It's really meant to be something you can turn on and use more or less as a black box once you've got it configured the way that you want to use it. It's a very high performance solution, so it's really designed at that implementation use case of being able to rely on the terminology server runtime from a clinical information system. However, you can also use it for analytics and for trying to draw content out of the terminology server to pack into reference data tables. There's an awful lot of use cases it will support. But because it's got that focus on that runtime use case, it's also had a lot of work gone into its searching algorithms, as Kate mentioned before. So the high relevance ranking, searching, Michael can probably tell you in great depths what's gone into that, but it's been years of work to have it return a very good set of candidate matches based on something that someone's typed into a search box, and we'll probably show some demonstrations of that later. But that's, as Kate mentioned, that's all aimed at trying to make the experience for clinicians as good as possible. It certainly does support generic fire code systems, but also has specific support for SNOMED CT and LOINC, and then also some expanded features of fire code systems such as supplements and even post-coordinated expressions under SNOMED CT. But certainly that key concept, and as I mentioned before, is that idea of managing the complexity of something like RF2 or then the native formats of all of the various code systems, and packaging that up and rendering that out as the Fire API to developers, so they don't really have to know what that underlying format is for that code system. And in Australia, as an example, we did this for the wonderful variety of little government code systems that we've got that come as PDF files, they come as tables on websites, they come as CSV files. And so we sucked all of those up and packaged them into the terminology server so that they can all be received from the same place. You can update them simply through the same mechanism, and they all come through the same API. And probably the last thing to mention on the features side, profile validation. So Onto Server will actually support validation of any fire resource. It will use the structure definition for that resource, and you can specify a particular profile if you would like. And it will obviously do the terminology binding validation for that resource as well, using the terminology it's got loaded, but it'll do all of the rest of the structure definition validation as well. So it's really quite useful for validating resources. But the core concepts to Onto Server definitely are the terminology subsystem resources. So code systems, which are things that hold codes and properties of codes, value sets, which are a resource that's designed for creating a set or a subset of codes that are designed for a particular purpose, and that can be either enumerated or it can be based on rules using filters, or in some examples like SNOMED CT using expression constraint language expressions. And then there's the idea of concept maps, to be able to map from one code system to another, or in fact one value set to another. But we'll probably get into more of the detail of all of those later. All of these have common metadata, things like identity, version, publisher, copyrights, those sorts of things. And there's a series of operations for each one of those resources. So you can expand a value set, which is to say, tell me enumerate out all of the codes that exist in this value set, and that might require the server to evaluate a set of rules to determine that. Or validate code. I can say, is this code in this value set or in this code system, and is this the right description for it? You can do lookup to look up the details of a code from a code system. Translate's about translating from one code system to another using a map. And closure and subsumes are about understanding the hierarchical relationships between concepts. And then overall, that can be wrapped up in, all of those things can be wrapped up in a batch operation. So you could send 1,000 lookups to the server in one big batch operation to reduce the latency across all of those lookup operations. And then, as I mentioned before, there's the validate operation, which currently is to support validating resources. So as a result, Onto Server also supports the structure definition resource as well as the bundle resource. So I've covered a bit of this already. Very deep SNOMED CT support, which is sort of really where Onto Server originally came from. But certainly a lot of other support for all of the rest of the fire code systems as well. And as a result, in SNOMED CT, there's a large number of implicit value sets defined. So for those not really familiar with fire has this concept of implicit value sets as well as explicit value sets. and they're based on the definition of the code system themselves. So those for SNOMED can be based on hierarchy, they can be based on ECL. There's reference sets available in a particular SNOMED edition. They automatically become implicit value sets. And all of these things can be really useful as a way to ad hoc query the server, or as building blocks to be able to create explicit value sets. And it's quite a powerful mechanism. The searching, as I mentioned before, that is essentially filtering on an expand operation on a value set, and it uses essentially word prefix any order searching, and it uses this sort of state of the art custom scoring function that can provide really good relevance ranking. There's support for obviously for multiple versions. SNOMED CT expression language support is quite deep, including cardinality constraints and even concrete domains. There's post-coordinated expression support, so you can have expression libraries, but you can also do things like use the subsumes operation and parse it expressions to look at how an expression relates to a concept or another expression. And then there's obviously a lot of support for the FHIR code systems, their properties, value set filters, code system supplements, etc. And as I mentioned before, content syndication, which I'll go into in just a little bit more detail now. So the idea of Onto Server and certainly NHS Digital's vision is not just for sort of one big terminology server in the sky, which has a lot of sort of technical challenges, but and also governance challenges. But it's really to be able to provide, out of say the NHS Digital's instance, a one-stop shop for all of the relevant content that NHS Digital are responsible for. And that can then be syndicated down into other people's servers, where they can augment that with other content that they may need for their local circumstances. So that's sort of the idea of this diagram, showing that we can pull content down from SNOMED International into sort of a national release center, which has all the national codes. And then ultimately other types of operators like vendors or some sort of regional center can pull that content in and augment it as they need to with the local code systems. That enables them to be able to not just govern what content, when they update that content from that upstream service, but also what content is loaded into that server and what additional content is loaded into that server, and to scale the operation that they have of that server for appropriately to the application that they're running, and know that they're going to be able to meet the sort of SLAs and performance and requirements that they need, without paying a bunch for something that's way over the top, or relying on something that's not adequate for their needs. So I won't labor this. This is the supported use cases. It marries very much to what Kate said before about the use cases for the overall concept of the terminology service in general, but this is what Onto Server is meant for. Obviously very much for data entry, and we'll go through some of that later. Validating codes and validating resources, being able to learn about codes once you've got a code, to find out more about it. Certainly mapping and translation, analytics, which can actually use mapping and translation, but also being able to do quite complicated queries of terminology to answer questions. And then it can also author, it can be used as an authoring server to be able to make code systems, value sets, and concept maps. And it has quite an advanced sort of notion of security, so that you can collaborate with people who may not be even within your organization on that content and share that content. So this is just a list of case studies. Again, and we can probably go into this in more detail later, but around the world, sort of CSIRO's been using this technology with a bunch of different people. So obviously Australia, New Zealand, there's a fair bit going on in Germany as well at the moment, Wales, who we'll hear from later. And so there's quite a bit spread across the globe. It's that this solution being rolled out for NHS Digital in many ways is very similar to the one that Kate and I rolled out for Australia, the National Clinical Terminology Service, which sort of serves a very similar purpose. And then, as we mentioned before, NHS Digital, there's the Wales Informatics Proof of Concept, which is transitioning into national service, which I'm really interested to hear the talk later, which is going to be great. As I mentioned, the HIMED Consortium in Germany have 8 university hospitals running, and there's clinical colleges and things in Australia and Switzerland. So there's plenty going on around the world, which is great.
And we missed Netherlands off the list, Dion. We forgot NICDIS.
Oh, yes. Yeah, so the Netherlands have procured a sort of a similar national terminology service and loading their content into it, and which is great, and heavily using some of the new cool features in FHIR code system supplements and things as well, which is great. So the solution, so again, yes, that idea of a one-stop shop of national terminology server, so that there's a bunch of nationally agreed code systems, value sets, concept maps that can be accessed via one API, a standard set of APIs that can be then pulled down into a federated set of other servers with using the syndication service. Makes it easy to pull that content in without large manual processes. And there's all sorts of double checking and that sort of stuff to make sure that the fingerprint of the files that have been pulled in is correct. So it's a sort of a safe content updates between those servers. But there's also a heavy community focus in the NHS Digital solution, which isn't really in the Australian solution, even though that's what we wanted, which we're quite excited about, to enable people running these servers to draw in people either sort of nationally, regionally, or locally to collaborate on content and then be able to share that content with each other, so that there isn't, just as there is in Australia probably at the moment, a collaboration going on nationally, and then there's a sort of a void after that. So we're really interested to, and hopeful in how that's going to work out. But critically, it does enable those whoever's running those servers themselves to have autonomy over what is in their server, when that content is updated, when they update the software of that server, what infrastructure it's deployed on, how highly available it is. So all of those decisions are completely down to them, and they can control that. There's as part of the overall framework, there's actually a service management wrapper supplied by DXC wrapped over the top of this, which can provide all of the other things you need to host one of these services, the actual hosting itself, but not just that, the monitoring, service desk, security, application support, all of that stuff that wraps over the top of a proper production operation. So for people who don't want to run that themselves, there's an option there to do that, which is great. But ultimately, that last point is probably the key point. It's really been designed to put the control in the hands of whoever is running their own Onto server instance. They can control who their authors and communities are, who's got access, what content goes into it, when changes are made to it, when the software gets updated, etc. So that's really a key part of the solution, because it's very much recognise that local autonomy is required to be able to rely on the service to meet those local needs, and that might not be in a massive high availability way. That might be in just understanding and having complete control over when content's updated. That might be a critical part to being able to rely on the service. This is a slide that's just indicating what the initial set of content is going to be loaded into the service. This will undoubtedly grow over time, or hopefully will grow with our colleagues in NHS Digital. So that's sort of the initial content. We do have a server for testing, which has got all of this content loaded into it. And we'll talk about that in the breakout sessions. Again, this is the sort of a rough solution overview diagram of what the NHS Digital solution looks like, and in fact what others can call off if they want, or can call off parts of this overall solution. It doesn't have to be all of these pieces, but the idea is NHS Digital is actually running 3, in fact 4 Onto server instances. One read-write aimed at authoring content and managing community collaboration through the authorization server. This syndication server, which is at Tomio, is being used to both pull in new indexes of SNOMED CT UK, as well as to take release candidate snapshots of content out of the authoring server so they can be statically deployed across to the staging server. Once they're happy with that content, can be deployed to production. And in fact, there's 2 production servers. One is being sort of used sort of as a general purpose server, and the other for a smaller cohort of users to guarantee quality of service for them for connection of runtime applications. So these components are quite flexible. They can be sort of mixed and matched, but that's sort of the general overview of how that solution works. And obviously Snapper and Shrimp are clients into this, but you can have many other different types of clients, clinical systems, or in fact other downstream Onto server instances that are pulling content, presumably from the syndication endpoint of the production server of the official released content. So this is pretty much an overview of what we were just talking about before of the ecosystem. This is a sort of fictitious example where we have NHS Digital, who have a bunch of content loaded through their Fire API. They may choose to collaborate with some other organization on the content of their server, and then offer up a syndication endpoint for others to be able to pull content. In this example, TrustY is pulling content from the national instance, maybe some of it, and they get to choose when they do it because it's a pull model. But then they might collaborate with Lycra A on some of the content that's in this server, and in turn they may pull that content from TrustY as well as from the NHS Digital server. The content that they're collaborating on could be value sets, could be mappings, could be other local terminologies, or code sets. It could really be pretty much anything. So implementation, we've effectively already talked about syndication, and I've probably labored it enough that it's a pull mechanism, so you're in complete control when you're running one of these servers. One of the things that gets confusing about these diagrams, people tend to think of it as a hierarchy or a tree. It's really like a graph. So you can configure your Onto server instance to pull content from as many different upstream sources as you like, or as few. You can have none if you want, and then you can choose which bits of the content you actually take from those upstream sources. So you're very much in control of if and when that happens. But it's also a great way of being able to collaborate on some content. You can choose to do that on your server or on somebody else's server, and then pull that content into your server. So there's a lot of options for sharing content essentially. The Fire API, as I mentioned before, it can be for individuals, or it can be for systems. It can be for using or can be for browsing and modifying the content via something like Snapper or Shrimp. Typically, that's what individuals do. They either browse it or they modify it. Systems are usually only connected read-only for being able to interrogate the data, either runtime or to pull content out of it in batch and use offline. But you can have read-write clients as well. So, for example, the NHS Data Dictionary is going to be integrated in that way, where the data dictionary content is authored off system, and then in a separate system, and then is connected up, and the content of it's pushed into the server. The national server will definitely meet some of the use cases people have, because it's got a whole lot of content that's probably going to be useful. Runtime dependence on a terminology server may well need a local server just to be able to meet the requirements that you have, particularly if you need other local content put into that server. So that's sort of a consideration. So really just looking at why might you go for a local server, or you might not need one, then you might be able to hook up to the national server and just use it for everything you need. It really depends on your use case. I suppose the major things that might move you from just using a national server, or the major considerations that might make you think about moving, are do you need autonomy over the content in the server? Do you need to be able to add in local content or be able to control when the content in that server is updated? Do you need some sort of local governance process over that content and how it's added and who gets access to it and when it's added? Do you need to control those content updates, as I mentioned? And do you have particular requirements for managing the availability of the solution? Things like latency, if you need to co-host it near something, if it's low latency is required, particular performance requirements and SLAs and those sorts of things. So they're the considerations. But obviously you're free to also use the national server within obviously its stated purpose, which I guess will be back over to NHS Digital. So, but definitely the NHS Digital solution is going to be a fantastic way for people to get connected, get started, and hopefully it may be all that's needed for a large number of people to be able to do what they need to do. And I think that's pretty much it for me and Kate.
Thanks. Any quick questions before we hand over to Michael to take to the next level of depth and talk about the fire spec itself? I take that as a no, and everyone is looking forward, Michael, to your Follow the Yellow Brick Code presentation.
Obviously, for everyone, any questions or anything, feel free to just send a message to one of us, and we'll have a look at the chat and that sort of thing.
There is a question in the chat, so just
Okay, sorry, I wasn't looking at it. Oh, it just disappeared on me.
I think Bukes, I'm not sure of your full name, but it says, what are the commercial implications of a local server?
We can probably pick up at the end of the session about the framework itself, and I'm sure Andy would be really happy to pop his details in, Andy Clegg from DXC, if anyone wants to email Andy directly. But maybe if we touch on the framework at the end of the session today, that just gives Andy and Dougal a bit of advance notice that to get ready to say something at the end as well.
Yeah, that's not a problem, Kate. And I'll bang my email in now if people want to get in touch.
Thanks, Andy.
Okay. Well, I think I've successfully shared my screen. So welcome, everybody, and thank you for joining us. I'm very pleased to be able to give this presentation, although I really do wish I was doing it in person. Quick intro to who I am. I'm the research group leader for health informatics at CSIRO's Australian eHealth Research Centre. I'm a computer scientist by background, so as Kate will tell you, a real geek. And I'm responsible for a number of technologies that we'll be talking about today. So Onto Server, SNOMED, which is under the hood doing post coordination, Shrimp, and Snapper. So today we're going to follow a bit of a story. We're going to follow some coded data through a journey, starting with where the codes get found in the first place, how the Fire Terminology Service API helps us with that, what these things look like on the wire, so we'll get to see some of JSON, how they get validated when they arrive at a system, and then how we might use appropriate APIs to query our data and use the codes in querying our data. As I tell the story, I'm going to use an analogy with Wizard of Oz, which was published in 1900 or so. It's in the public domain, including the images, which I'm using courtesy of Project Gutenberg. And a quick shout out to Jim Steele, who can't be with us today. He's in the middle of paternity leave with his first child. So I'm sure he's much happier doing that. And everything I'm going to talk about in this is actually generic Fire Terminology Services API stuff. So there's nothing specific to Onto Server here, but of course, it's always better with the terrific terminology server from Oz. So I'll start with a quick introduction of the basic Fire terminology resources. first key resource is the code system. The little N there means that it's a normative resource, and it's been normative since FIRE R4. And that basically means that there won't be any breaking changes to the code system resource going forwards with new versions of FIRE without extensive consultation with the community. So pretty much means unless there's something really drastically wrong, this is a stable resource. And so a code system represents a set of concepts with a coherent meaning. It has a public identity with a URL. It may have a version, a name, set of filters and properties. The codes themselves, synonyms, display text, definitions, and associated properties. So it's not designed to represent everything about really complex code systems like SNOMED CT, but it's certainly the operations are capable of working with the complex semantics of something like that. But for most simple code systems, the code system resource is more than enough. The next resource is the value set resource. It's also normative, and value set is used to identify a set of codes for use in a particular context. It does that by through the use of a compose section, so that it's definition or its intentional definition. But it can also have an extensional definition, and we'll see more about that as we go forward. The third resource we'll talk about is the concept map. A concept map is a way to represent relationships between codes, usually in two different code systems, although occasionally within the one code system. An example there, for example, comes from SNOMED CT, where there are concept maps that capture historical relationships. So an inactive code that maps to a new active code that replaces it. And concept maps are contextual. So maps are up for a purpose, and they can be contextualized by specification of both the source and the target value set. So the essentially the domain and the codomain of the map. And then there are a set of operations that are applicable for these resources. So the code system comes with a lookup operation, validate code operation, and the subsumes operation. Lookup lets you find out properties of the code and its synonyms. Validate code lets you check whether a code is a valid member of the code system. And subsumes lets you do hierarchy testing. So is this code more general or more specific than another code, usually in the same code system. Probably the most common operation that you'll come across is the expand operation. And expand takes a value set definition, interprets it, interprets the inclusion and exclusion rules, and produces the set of concepts that match those rules, so that satisfy those rules. It returns another value set which lists the codes that are in the extension or the expansion of that value set. Validate code is on a value set is similar to expand, except you also supply it with the code. And what you're asking is this code a member of the expansion of the value set? And we'll see as we walk through our journey an example where the validate code operation is useful. And then we have translate. Translate operationalizes a concept map. So given a source code, what are the target codes it maps to, and what are the relationships of those mappings? So they may be relationships of equivalence, but they may be broader than or narrower than, or you may even have a code that has no map. And a concept map can actually refer to other concept maps, so it can sort of delegate delegate to off to other concept maps. So the translate operation will work through those delegations. The last operation we'll talk about is closure. Closure doesn't really operate on a concept map. It returns a concept map, and it's essentially a way to do a whole set of subsumption tests in one step. And it's really designed for analytics and query use cases when you're working with data. And we'll talk a little bit about that towards the very end of our journey. So there's several places where you may see or use the Terminology Services API when you're using a Fire-based system. You may be using a generic Fire server like Happy or Bonk. And these servers often provide at least a minimal support for the Terminology Services API. You may see a separate dedicated Terminology Server endpoint, as is common with Onto Server. And the separation out of a separate Terminology Server is a nice design paradigm for clients. And if you've seen David Hayes' ClinFire tool, he really provides a good example of why this is a useful way of architecting a client. You may have both a general Fire server or a rapid EMR with a Fire API sitting behind a facade alongside a terminology server, where the facade routes terminology requests to the terminology server and other requests to the Fire server. So it appears as a single endpoint, but in fact is serviced by multiple separate backend. Or you may have a Fire server that itself is integrated with an external terminology server, and so it does the delegation and also uses that external terminology server to provide advanced functionality, where the functionality goes beyond its built-in capabilities, and to support some of the more advanced Fire search functions, such as the code in and code below request types. So in our journey, first thing that happens is that our patient Dorothy decides to make an appointment with her local GP. She's not feeling too well, so she logs onto her GP website. Her GP is Dr. Oz, and she starts filling out the pre-encounter form. She provides some demographic information: name, age, gender, reason for a visit, and some family member history. So who might have had relevant conditions and what their relationship is to her. And as she's filling this out, she's providing a set of coded data into the form. So we're going to look at how the Fire Terminology API supports the collection of those values by the form. So first coded value was gender. And so under the scene, under the hood, what's happening is that server is doing an expand operation and is finding all the appropriate gender codes. So it's looking up with the URL parameter, the expansion of this gender value set to find out what are the codes that are relevant. And what it gets back is a value set with an expansion element, and within that a contains element, and in the contains element are the codes. So we see here that there's 4 codes. For each code, it tells us what the code system is of the code, because a value set may contain codes from different code systems, so you need to know which code system the code is from, and the display text. So you can build your user interface around this. You get back the display text that you can put up, and then when code is selected, you've got the code and the system that you can put into your backend data. The other information that's collected is the family member relationships. And so in this case, we're doing another expand operation. But instead of specifying the value set directly, we may not know what the value set is. So we're using the context parameter to say, use the value set that is bound to this, this element in the family member history resource. The terminology server knows what value set is bound to that element. And so it can look that up and use that value set. Whoops, that's not good. And return the results. And so here we see that we've got an expansion come back. We've got 105 members of this value set. And I should say also that the order of the codes here at this point is arbitrary. It's up to the server according to the FHIR specification. Often the order might be influenced by the value set definition itself or the order in the underlying code system. And sometimes the order is essentially random. Okay. Now, if we look at Dorothy's reason for visit, here we're doing another expand operation. We're using the value set bound to the reason code in the encounter resource. And this resource may have, if it's something like SNOMED, may have 100,000 possible codes in the expansion. So we don't want 100,000 codes to come back. So Dorothy's not going to sort through that list and pick them out. So she's typed in some search text, and this has been provided to the filter parameter. And what that means is that the expand operation only returns in the expansion the set of codes that match that filter text. Now, what does match mean? Well, that's up to the terminology server. It decides based on its knowledge what the most appropriate interpretation of match is. And as a general rule of thumb, word prefix any order is a really good matching algorithm. In fact, there's a lot of published literature that indicates that it is one of the best matching strategies for this kind of user interface. And so that's what Onto Server employs. What Onto Server also does, and different terminology servers may do this or do different things, it also orders the results in the expansion based on a best match. So here we see that we've got 6 matches. The top one here is accident caused by tornado, and that's the one that Dorothy is going to select. And once Dorothy's filled out the form, the GP system will have a record of the encounter, and it might look something like this if it's using FHIR. And we can see here the 3 different data types that FHIR uses to store coded data. There's the code type, and here status is planned, and so it's just a simple code. We don't need a code system here because the underlying resource definition tells us that what the code system must always be, so we don't need to redundantly store it. It's already there in the metadata effectively. Then we have the class, which is a coding typed entry. Coding allows us to indicate what the code system is, the code itself, and the display text optionally associated with the code. It's optional because the code in the code system it comes with display text, but it's generally useful to provide the display text as well. And the third type we have here is the codable concept. So this reason code is a codable concept. Codable concept consists of 0 or more codings. So we see here a single coding, and this single coding also includes the extra field user selected, so that we're going to indicate here that of the codings, this one was actually the one that was selected in the display. There may be additional codings that are there as a result of maps or translations, or that have been filled in by the back-end system for other purposes. And then there may also be some just free text. And so with a codable concept, there may not have been an appropriate code. And in that case, you would have no codings and you would just have text. And that's kind of the opportunity to do a sort of an escape where the set of codes that have been provided doesn't cover the case that you want to represent.
Michael, there's a question in the chat around the value set context. How is the value set context included in the query? I use my encounter code rather than your encounter code.
So when you specify the context parameter, that either refers directly to the resource, and so you would be looking at the binding that's in the resource, or it can refer to a structure definition or a profile, as it were, and the binding in that profile. So when you specify the query, that's when you when you specify that parameter, that's when you select which particular piece of context is going to be used for the expansion to identify the value set. Of course, if the terminology server doesn't have access to that profile, then it's not going to be able to resolve that to a value set. And this is one of the reasons why Onto Server supports structure definitions, so it can support the use of the context parameter. So Dorothy has her appointment with Dr. Oz now, and he takes some encounter notes, some social findings, her housing status, some diagnosis codes, and he diagnoses her with concussion, with loss of consciousness, has imaginary friends, and a pleasant fantasy. And he decides that he needs to refer her off to his colleague, Dr. West, for a psych eval. So when he's selecting the housing status, it's yet another expand operation, and this time we're referring to a value set. But in this case, the value set's not an explicit value set on the server. This is an instance of an implicit value set. So some code systems, notably Loink and SNOMED, define quite a range of implicit value sets. And these are value sets where the URL itself follows a pattern and contains within it sufficient information to infer the definition of the value set, so the rules for inclusion and exclusion. And so a terminology server that knows about these implicit value sets can decode their meaning from the URL and then do an appropriate expansion. So this particular value set is an answer list value set, and this is the code for the answer list, and the expansion of that value set are all the answers to that particular question. Loink in particular has a large number of these implicit value sets. And so we get the expansion coming back. It's the usual form, and Dr. Oz is able to select the appropriate code. Now, SNOMED also has implicit value sets. This one in particular is based on hierarchy. So this format here with the ISA says all codes are the descendants of this code or equal to this code. So this is actually clinical findings. So it's a very broad value set. It has 100,000 members, depending on which version of SNOMED you're using. Now, in a user interface, you don't want them all to come back at once. So you only want enough to fit in your user interface. So here we've used the count and offset parameters to say we want the first 10 in the expansion. So just give us those. If we need more, we can change these parameters and rerun the request and get back additional ones. We're also asking for the designation. So by default, a server will generally just return the display text of a code. But you can also ask for all the designations. So you get back all the synonyms, and that may be useful if you need to operate in a different language, or you have a slightly different context of use and you want, for example, patient-friendly terms to display rather than the default display text. So in this result, we can see that this code has imaginary friend, comes back with a couple of designations, one of which is the SNOMED fully specified name. So this use provides a context for the different designations. So you can have synonyms, fully specified name, display, patient friendly, and it's actually, this field is bound to an extensible value set, so you can have potentially arbitrary uses for different contexts. So now Dr. Oz sends his record across to Dr. West as part of the referral, so that she has a proper patient history, and Dorothy doesn't have to recount her patient history and then re-enter or re-provide all the data when she arrives. And Dr. West's system receives the record and probably has some profiles that govern the exchange of information with other systems and ensure that the information that's sent is understood appropriately. And so it needs to perform validation. So it needs to validate these resources. And there may be a set of resources, patient encounter, the service request for the referral, the conditions, family member history, and so forth. And so all these resources would need to be validated. So FHIR has a validate operation. The validate operation is actually defined on every resource type. So, and Onto Server itself supports the validate operation on all resource types. And to perform validation, one of the key things is to ensure that the codes that are in the fields are suitable for the fields they're in. So it makes a lot of calls to either explicitly or under the hood to the equivalent of a value set validate code operation. So one of these calls might look like this. So we've got a call to validate code. We're saying this is the value set that we're validating against. So again, an implicit value set. This one happens to be a ref set based implicit value set. And so every SNOMED reference set has a corresponding value set with a URL like so. And the expansion of that implicit value set is all the members of the reference set. So this is asking, is this code from SNOMED a member of this reference set? And what comes back in this case is the parameters resource with the result true, and for convenience, the display text for that concept saying concussion with loss of consciousness. So we're happy that this code is appropriate for the field because it's a member of the value set. And now we're validating another code. And this time the request is providing the display text as well. So it has imaginary friends associated with this code. But this time, what comes back is a result false. So what's really happening here is that there's actually two questions being asked. One question is this code a member of the value set? The other question is the display text here the right display text or an appropriate display text for this code. And what's happened is that Dr. Oz has, or his system vendor has tweaked the display text and added a pluralization. So changed has imaginary friend to has imaginary friends. And so this is coming back saying that this is not an acceptable synonym for this code. And then of course, having failed validation, appropriate workflow has to kick in to deal with that problem. Now, Dr. West, after performing her psych assessment, completes her record. And she diagnoses Dorothy with depersonalization disorder, reactive detachment disorder, and adds those to her record or to the local record. These are all SNOMED codes. And for treatment, she's going to prescribe this code RBSLPTAP3. And for some reason, her system collects these codes. It's a local code, so it's not standard code. It's just in a local code system, and it actually collects them as codes, which is not good practice, but yeah, legacy software. So Dr. West then submits her record to the HIE as part of the funding reimbursement process. And the first thing the HIE wants to do is do some code normalization. So it needs to translate the codes into the appropriate codes that it needs to drive its billing rules. And so they've built a custom map from SNOMED to ICD-10 codes for these billing purposes. So it's not actually a semantic map, it's a billing map. And the first two codes map just fine. Consciousness, concussion with loss of consciousness maps to this concussion code. Depersonalization disorder maps to this depersonalization code. But the reactive attachment disorder doesn't have a map. And neither does this local code. So FIRE has some things that can help us with this mapping, as well as diagnosing what went wrong. So to do the mapping, we're going to use the translate operation with concept map, and we refer here to the concept map to use, which is this custom SNOMED to ICD-10 map. We refer to it again by its URL. The target value set, so the target for our map is going to be ICD-10 codes, and this is the code that we want to map. So we call translate on this, and we discover that there is a result, and that we look in the set of matches, and in this case there is only one match. It's an equivalence match, and it's this S06.0 concussion code. We also have this source output parameter telling us which concept map the map came from. So if you remember, I said earlier that concept maps can delegate to other concept maps. So if this concept map was using some, it was composing together a set of concept maps, then we'd be able to see which map ultimately provided the code, rather than just the top level map. But what about the unmapped code? So let's use the lookup operation to find out some information about this unmapped code. So here we're doing a lookup on the code system. Code system, of course, is SNOMED, and this is our code. Couldn't map. And we get back a result, and this result gives us this display text, the version that was used to provide the information. And it tells us that this code is inactive true. So this is an inactive code. So that's probably why it's not being in the map. And so what are we going to do about that? Well, SNOMED again happens to provide some implicit concept maps. So SNOMED fortunately delivers a set of historical association reference sets, and one of those is the replaced by reference set, and it's exposed as an implicit concept map. So we can do a translate using this implicit concept map. This is the URL for it. And when we look it up, we can find that the code has been replaced by this other code. And we don't know exactly what whether this is an equivalent code. So the equivalence here is inexact, but it's probably going to be something that's useful to drive our billing processes. And so our HOE might actually update its pipeline for the way it deals with codes to first check these historical association concept maps to migrate retired SNOMED codes through to their replacements. So sometime later, researcher Glinda is doing some analytics. She's doing a study on treatment paths for patients with mental health conditions, treatment pathways for patients with mental health conditions. And she first tries to build a cohort of patients with conditions relevant to her study. So she starts with a simple value set, which is all SNOMED codes that are descendants of mental illness SNOMED code. So this is expressed in an implicit value set. And she can use her FIRE server, do a search request. So this is a search request. She's looking for patients that have a condition of which they're a subject, where the code is below this is a mental health condition, and she discovers that she's actually getting a few too many codes that she's not interested in. And how does this work under the hood? Well, the FIRE server has to find out what all these codes are. So it might expand the values and a value set to get the set of codes of interest, and then join it against its the codes in its local table. It may know that this is a common request, and so it may cache some of this information. It may actually use the closure operation to do this. So the FIRE server actually knows what all the unique condition codes are. And if it knows that there's going to be a lot of these sort of code below types of queries, then it might want to keep a local cache, local knowledge of what the hierarchy is between the codes, these condition codes. And for that, it can use the closure operation. So the closure operation is actually has a protocol associated with it. Doesn't do anything very useful in a single step. So we'll walk through the steps in using the closure operation. The first step is to initialize a closure table. So we call closure, we post in a parameters object, and we give a name for our table. And this is going to be we use the same name all the way through. The next step is, what we get back as a result of that is a concept map that's empty, and it's version 1. So we've initialized it. We know the version is 1, so it's the very first step in our process, but it's got no information in it. We now get all the codes that are in all the condition codes that are in our data. In this case, we happen to have only 3, and we post those again to the closure operation, again in a parameters object with the same closure table name. We send those in, and what we get back is another concept map, giving us back all the hierarchical relationships between these codes. Now, So it happens with these three codes that there is no hierarchy between them. So again, we get back an empty concept map. We know that this is the response to our request because it's version 2 and the previous one was version 1. So we know we're at step 2 of our interaction. But now we've got our query that's come in saying all codes below 74732009. So now we can provide this query concept into our closure table saying, here's another concept, give me all the hierarchical relationships between this concept and everything else you've got. And we get back our concept map, and now we've got some data in our concept map. And we see that, that there's a subsumption relationship. So this code does subsume one of the codes in our data. And so now we know that all the conditions with this code, 707640005, are codes of interest. Now, as I said earlier, Glinda discovers that actually all codes are descendants of mental health means that she's finding too many records of associated with drunken munchkins, with alcohol-related disorders, and they're not of interest to her study. And also at this point, she's not interested in intellectual disabilities. And so she wants to exclude those codes from her cohort. So to do that, she's going to construct her own value set. So to build a value set, we have a set of building blocks. So the value set compose is the element that you use to define the rules for inclusion in a value set. And it has two subparts, the include and the exclude criteria. And within that, there's 4 different ways that you can specify those inclusion and exclusion criteria. So you can include the whole of a code system. You can include members of another value set, or exclude if you're in the exclude section. You can include specifically listed codes from a code system. So you can enumerate a set of codes, or you can provide a filter, where a filter consists of a property, an operation, and a value. So it might be something like the property might be concept, the operation may be ISA, and the value would be a code. Or the property might be something like lateralizable, and the operation would be equals, the value could be true. So I would find, assuming that your codes have a lateralizable property, or there's a lateralizable filter defined for the code system, it would just match those lateralizable codes. You can specify multiple of these building blocks, and this sets up a mechanism to combine the criteria with both ands and ors. So within an include, all the criteria have to apply. So you get the and semantics. So if you specify multiple value sets, then the codes have to be in each of the value sets. And when you have multiple includes, then any of the includes apply. So it's the or semantics. That gives you a really powerful set of building blocks to express your inclusion and exclusion criteria. And then when the terminology server evaluates this, these rules, it does so by first evaluating all the include criteria. So finding all the candidate codes and then processing all the exclusions. So then eliminating any excluded codes. And the rules for this evaluation are carefully defined so that the results are deterministic. And so every terminology server, when it does an expansion, should get the same results for the same inclusion criteria with the same underlying code systems. Of course, with different versions of code systems, you can get variation in the results. So this is what Glinda's value set compose looks like. She's including all the mental health codes, so every concept that is a mental health concept. And then she has this exclude section. So she's excluding all the codes that are descendants of intellectual disability. And then she's got these additional exclude clauses. Now, these are filters with the constraint. So SNOMED defines the constraint filter, which allows you to use SNOMED's expression constraint language. The expression constraint language is a very powerful query language against the SNOMED hierarchy and its relationships. And so you can see here an example of one of these ECL expressions. And so what we're looking at here is all codes that are mental illness codes, so descendants or self of mental illness, that have some kind of an association, so the associated with relationship or any of its more specialized relationships, to a drug, to any kind of drug. And this second ECL expression is, again, any mental illness concept that is associated in some way with alcohol or any of its more specific codes. So this value set now excludes the two cohorts that Glenda's not interested in. And so she may want to test her value set before she starts going off and doing her analytics. She can post the value set to the validate operation. That will check, for example, that her ECL expressions are syntactically correct and don't use invalid SNOMED codes. And the other details of the value set definition are all okay. And then she may want to just examine the expansion to make sure it's actually doing what she wants it to do. But she may not want to actually make this value set definition public yet, so she doesn't want to create it on the terminology server. She just wants to get back the expansion. So to do that, she can actually post the value set definition itself to the expand operation and do what's called a dynamic value set expansion. So the terminology server, it receives that value set definition, interprets it on the fly, identifies all the appropriate matching codes, and returns the expansion. This sort of dynamic value set expansion is really useful for certain types of user interface and tools where the definition might depend on other values that have been previously entered, say elsewhere on the form. And it's also something that's made heavy use of in the terminology browser Shrimp. So Glenda's now happy with her refined value set. She's uploaded it, she's given it a URL. This is her mental health value set. So she's now able to construct a query looking for the patients that have conditions, which they're a subject, and the conditions code is a member of this value set. Now, before, when the previous query had code below, and so the server was able to use the closure operation to assist in efficiently evaluating the query, but there's no closure equivalent for value set membership. So what is the server to do? Well, one option is to expand the value set, get back the set of results and do a local join, maybe put them into a temporary table and do a local join. But that's not going to be great if that value set is extremely large, or in some cases that value set may be infinite. And in theory, that is the case with SNOMED if your data has post-coordinated expressions, for example, or there are other code systems that have value sets with infinite expansions. So you need a bounded way for the server to perform this code :in evaluation. And so we have, again, dynamic value sets to the rescue. The server can extract the unique set of codes in all the conditions, construct on the fly a value set consisting of those codes and intersecting it with our mental health value set, and then ask post that to the terminology server and saying, expand this value set. Now that might be a very large set of codes, so that may be a fairly expensive operation. So if the server knows that the data is not changing, it's in an analytics environment, the data is not changing too frequently, it could pre-construct that value set of the codes and the condition, store that on the value set ahead of time, and then just send a small dynamic value set that just says intersect these two value sets. Then if the data ever updates, it can overwrite the value set on the server. So it's delegating that intersection operation off to the terminology server rather than doing it locally. So Glinda does her analytics and she discovers Dorothy. And having found Dorothy in her as a member of her cohort, she's interested in Dorothy's treatment pathway, and she wants to know more about this RBSLPTAP3 code. Unfortunately, one of her colleagues has a map from the proprietary procedure code system to SNOMED CT. So what Glinda wants to do is both look up the code in the local code system to find out its properties, but also see what it translates to via this concept map in SNOMED. So in this case, she's going to do a batch operation. This allows you to talk to a file server and do multiple requests in one step. So do that by creating a bundle resource with a type batch, and each of the entries in that is a request. And so we see here we've got a request with a get method to code system lookup. So this is looking up our code in the proprietary code system, and a second request which is doing a translate of our code using the her colleague's map and looking for the SNOMED code that it translates to. And what comes back is a bundle of results. They're correlated. So the first resource coming back in the result bundle corresponds to the first request, and the second resource that comes back corresponds to the second request. If any of those requests fails, then you still get a bundle back, but the result is an operation outcome resource, which gives you details of the failure. So she sees that this local code is tap your Ruby slippers 3 times and say there's no place like home. And she also sees that this maps to the corresponding SNOMED code, magical thinking. And so Glinda discovers that this procedure has been successful. And so she recommends adding it to the standard treatment pathways for these mental health disorders. So what have we learned? We've gone through some of the terminology operations, a large number of them, in the FIRE specification and what they do. Expand operation, which gives you back the matching members of a value set. And validate code, which lets you test whether code is in a value set and check whether its display text is acceptable. A translate operation to use a concept map, lookup operation to find out details about a code, and a closure operation to deal with hierarchy relationships amongst a set of codes. We've also seen how to invoke multiple things in one request. We've had a quick example of making your own value set, and some of the pathways for integrating the search functionality of a FIRE server with an external terminology server. So if you're excited by this, and after this session you're looking for more help on how to use the FHIR API, the best place to go is the FHIR community, the online community. It's very welcoming. It's in the FHIR Zulip server, which you'll find at chat.fhir.org. And in particular, the terminology stream. And that's the best place to ask your terminology questions. There's also a SNOMED specific stream if they're really SNOMED specific questions. But they're welcome on the terminology stream as well, of course. So thank you very much for your attention. And I will pause there and see if there are any questions.
Thanks, Michael. Thanks, Michael. Kate, would you like to introduce the next part?
Yeah, absolutely. Thanks so much, Helen. So hopefully that's given you a good introduction to kind of the high-level overview of the NHS solution, and also Michael has done a good deep dive around FHIR. I'm happy with any FHIR presentation that discusses shoes, albeit briefly. So thanks, Michael, for that example, and that's certainly hopefully given some more information around the actual API itself. But I'm more interested in the next session, which is actually presentations around those who've actually been implementing the FHIR Terminology Services API and Onto Server, and actually hearing from Tracey, Charles and Richard over the next session with some real life examples. So first up, I think we're going to hear from Tracey, who's going to talk about the work that National Health Service Wales Information Service has been delivering for and working towards over the last couple of years. And Tracey, I'll let you explain it. And I'm really excited to see how far it's progressed since we last saw you up to. So over to you.
Thank you. Bear with me just as I sort out my screen share. Can you see my slides okay?
Yeah, that is great.
Yeah. And actually my presenting slides, not my other slides. Could I hear Becca then?
Yeah, I'm here.
Thought I could hear you.
Okay, do you want me to start?
You start and then I can kick off then, yeah.
Okay, Bordar, everybody. Thanks for having us. Lovely to see familiar faces. Always enjoy learning more about Onto Server when I get to hear you guys. And I think we might steal that Oz story. That was really great. Thanks for inviting us to talk to you today. We've been on this journey for a couple of years now, actually, in Wales with the Terminology Server. So we set out our programme really around the implementation of SNOMED CT in Wales. Part of our digital strategy and our statement of intent is about ensuring that we've got clinically structured information across the health and care record for Wales. And as part of our journey around SNOMED CT implementation, we identified the requirement for a terminology server that could distribute it amongst other code systems and value sets that you've heard today. So Tracey's going to talk to you a little bit more about that. We got involved in the proof of concept with NHS digital colleagues. I mean, it feels like yesterday, but I think it's been about nearly 2 years now, probably. Huge amount of learning on the way. We're really, really proud to get to where we are today. We are just about, I think it's fair to say, I keep saying this and it extends, but we're just about to switch on our production instance of Onto Server in the NHS Wales architecture. So we've been through a bit of a journey actually in terms of things like infrastructure design. Obviously Onto Server lives in Docker containers, something that was new to the architecture in Wales. Obviously it's cloud native for us, our first sort of live component of the platform that is only living in the cloud and not on-prem. Nervousness for our data center colleagues. I guess you'll hear a lot about the framework today, which I think is fantastic for the home countries across the UK to be able to call off that, depending on what sort of levels of maturity you're at, or whatever your use cases are. It's really flexible. Because we were part of the journey for a really long time, we did a lot of the infrastructure and hosting and service management reps ourselves in Wales. So for that reason, our contractual arrangements are largely around the sort of the software offering as opposed to the additions in that. So I think that's just a bit of a setting the scene and context. We didn't know how much time or sort of what level to keep the presentation. So it's a bit of an overview and a bit of a feel for what we've done with it so far. And we're happy to take any sort of in-depth conversations offline, or defer to our more technical colleagues if you're going to ask us tricky questions. So I'll hand over to Tracey.
Okie doke. So as Becca's set the scene, I shall make a start. So our project's remit was to deliver SNOMED CT, as Becca said, to the digital healthcare record for Wales. Being SNOMED focused, and we had the ministerial policy that was published in 2015. Like I say, the project began then in 2017. So the team consisted of only a couple of members of staff, with working with an external company to give us some expertise and upskill, and like I say, set the scene really, and allow us to explore what tools that we needed then to be able to implement SNOMED CT across NHS Wales. So being our main focus of SNOMED CT, we sort of, where do you begin? Although SNOMED CT has been around for a very long time, my background is clinical coding, and as part of my examinations I had to learn about SNOMED CT, and I always thought it's never coming in, it's going to be years, it's never going to happen. We're there, so which is fantastic. So it was like, well, how do we raise that awareness? So we went out to all the health boards, we did awareness sessions. We developed a maturity matrix, which I'll go into detail. We come up with some principles and guidelines for all sorts of people to think about on when they're trying to implement SNOMED, because we know it is a difficult thing. So there's a couple of things to bear in mind. And obviously, what else do we need? We need a terminology server to be able to do those things. So, it was a key thing for us to be able to procure and implement the terminology server. And also it's about opening up that architecture, as part of our National Data Resource Programme, the terminology service is a key component to that. So, as I said, we went on now to develop some principles and guidelines. So, we need to make sure that it is useful. There's no point in recording SNOMED if it isn't going to be useful. We're recording clinical information at the end of the day, and it can't be unobtrusive. It needs to be flowing. We need to make sure that it doesn't interrupt the workflow. It's got to be consistent. So when users are searching SNOMED CT, they've got the same look and feel of it when they're using it across different applications. It needs to be quick, and it also needs to be precise. So they were the sort of key things that we felt that everybody needed to be aware of and abide to them when they're developing their applications. So then we started thinking about structured data. We're trying to move away from free text. So what sort of UI possibilities are there? You've got your radio buttons and your checkbox and your observations, and then you've got your selectable clinical terms, very familiar with drop-down lists. You can't fill the screen with too many on there. You need to think about, well, what sort of size would we be looking at? And then if you're trying to search over large value sets, how would you then do that? So these are just, like, as I said, the basic things to think of. Then we move on to sort of storage, so what would you store? You're using SNOMED, so what would you then, store in the database? Would it just be the concept ID or the preferred term? So there's those things to think of. Messaging then, what format would the data be in? If a system can't accept SNOMED CT down the line, would it need to be the preferred text? And like I say, raising the awareness then, there are reference sets out there to be used, which can constrain your search, and how would we go about using them? And there's also some that are approved, by Royal Colleges. So we try to raise, all of those sort of awareness to users of clinical applications, and to bear those things in mind then for the developers and when they're gathering their requirements for their each system. So like I said then, so we developed a maturity matrix, which, let me just hide that, which was published back in 2018 as a data standard change notice. So this describes all the levels of SNOMED CT implementation in electronic systems. So in order for you to derive the benefits of its use within the electronic health record, you need to consider, you know, the information model on which such systems are based on, how effectively they can be used, the structure of such systems in respect of a standardized data capture, analysis, supporting individual patient care. So there's a lot of different things to think about. So we'll identify different levels then of the sophistication in relation to SNOMED CT, and these levels range from no use of SNOMED CT to right the way through to advanced use of SNOMED CT, being able to exploit them by the system. So the matrix was intended to act as an educational tool for the developers and procurers, and also to help gain an understanding of what can be used and what can be done then when you're going through that procurement process and when you're looking at applications at data item level. So moving on then, we were looking at, well, what would our use cases be? So we've already heard about, you know, sort of syndication and dynamic. We need to get the content into our application. So the syndication process is massively important, and being able to use it through a standard FHIR API is been fantastic. You know, it's easy to update, it's automatically downloaded, has multiple versions. And like I said, it can hold all sorts of code systems, value sets and concept maps. But for us, we sort of focus more on the dynamic use cases. So being able to intelligently search and dynamically call the terminology server and being able to set out value sets that we can search over. So that's been sort of our sort of main drive for us. So you've heard what Onto Server can do, so I'm not going to go into too much detail on that, but in supporting opening up the architecture, like I say, the Terminology Server has been key to enable that in NHS Wales. It's with it having its, you know, ranking algorithm, it ensures the right codes appear at the right place. You know, where it sits within the NHS Wales architecture on screen, you can see it is a key component. It's so important to us, and that we've been able to build it within our infrastructure. You know, as Becca said, it's Docker. We've had to learn a lot along the way, but it's been really useful, and getting our infrastructure team on board has been really good. So following on now, like I say, we've had our proof of concept server running for a couple of years now, and we're just so close into getting up. Well, our production environment is there ready, it's just waiting for it to be sort of switched on. But we're always engaging with projects. So we always try and engage as early as we can. And one of the first projects we engaged with back in 2019 now was an outpatient continuation sheet for a clinic for myeloma. So the high level requirements are on screen. You know, they wanted to develop a data solution that can be used across Wales, and it needs to be able to record and capture that information. And it'll hopefully, well, should then, you know, they'll be able to look at patient outcomes and be able to enhance their quality of care. So the way that we wanted to do this was to provide that support on what sort of SNOMED content that they would need. And it's all about replacing that paper record, but we needed to get in there early so that they understood what SNOMED was. So we did a number of awareness sessions with them, met with the developers and the senior responsible officer, and really got into the detail of, well, what are the things that you want to record, and then started to work with the developers. So it's implemented within existing components and services of NHS Wales. We had a couple of test cases that we could look at, and we did a couple of demos. We provided a small amount of training on the UI because it's so intuitive anyway, but we sort of said, you know, it's multi-prefix search. So it's just getting that user to think a little bit differently maybe on searching. Some people, you know, look down at the keyboard, type the whole thing, others type the first couple of letters and see what's returned on screen. So it's how the user would engage with the system. Like I say, we constrained the search using SNOMED CT's ECL, and we did the lookup on clinical findings, but we found it relatively easy that if there were any changes that we needed to do, it was fine, because it was just a case of changing the API parameter and passing it back to the developer and then being published into production environment. So it was fairly straightforward, should we say. So like I say, we were covering diagnosis and past medical history for the outpatient continuation sheet, and there's just an example of the ECL on screen. So we were quite high level, using clinical findings, super type hierarchy, and obviously past medical history then for a situation with explicit content subtype hierarchy. The application has been used now for over 12 months. So we're gathering quite a bit of data now with SNOMED CT, which is fantastic. This is a little screen clipping of the user interface from our production myeloma application using, as I said, the API described in the previous slide. So it uses a simple type ahead search. And as you can see on screen, you know, you start typing a couple of things in and it's the one at the top. So, you know, it doesn't require a browser. Quite a lot of people see the SNOMED CT browser and think, oh, what's that going to look like in an application? So we have, over the past couple of years, developed a few demos so that we can say, well, this is what it's going to look like in your application to an end user anyway. So like I say, simple requirements, using SNOMED CT dynamically, you know, it provides that quick return, accurate diagnosis. It searches over synonyms and it stores the preferred terms and concept ID and the text. So that's just a little quick stop over how we've implemented it in the myeloma outpatient continuation sheet. We've also looked at some live data. So just to give you a quick example, because we're often told, or we've often got quite a bit of data, free text that we look at, and it's the spellings and all sorts of different things coming up. So in a previous presentation, we did some live engagement where we asked you to have a go at spelling penicillin. So we actually looked at some live, so this is from one clinical application over a 12-month period. And there were 21 different ways to spell penicillin. So we just wanted to sort of show, well, how can OntoServer, SNOMED CT and SNOMED ECL be used to try and reduce this? So just to show, you know, if you using that dynamic lookup, you know, assuming the user's interaction I was to enter every single character of their version of penicillin, this return on screen, you know, you can see it eliminates each of the misspellings per keystroke. Whereas if the user was to enter in PEN, so we've constrained this over substance, and it's within the top 10 entry. If they entered one more letter, PENI, you can see then it's the top entry. So we've constrained this to search over substance, which is 27,500 concepts, applying that type ahead, and it, as I say, it constrains that list. So pen returns 185, and then when you type in PENI, it returns 43. Whereas if you didn't have the constraint, you know, you would be searching over a huge amount of SNOMED content and probably inappropriate as well. So it's really key to engage with the team terminologists to make sure, you know, you're capturing and recording and you're constraining what it exactly is you need for the application. So, and this is quite short and sweet. So what I've just put on here now, sort of what we've achieved over the last, should I say, 18 months to 2 years. So we have been able to download SNOMED CT index content from NHS Digital Sphere server. We've implemented it in a pilot, as I say, in the outpatient continuation sheet. We've uploaded a concept map. We successfully viewed our SNOMED content using the browser. We're using the standard Fire APIs and being able to consistently search, have that same look and feel across the digital healthcare record. We've published a code systems and value sets. We're still early days on that. There's still a huge amount more that we want to do, but it's been a little bit, like I say, we're waiting for the production server to go live and we can really get to work on that. As I say, one of the not difficulties, but it has been challenging, was the infrastructure design for us. We've had the invested time from our infrastructure colleagues, which we're really grateful for. They've done a huge amount of support for us. And being able to produce a really good infrastructure design that supports OntoServer. We're still, as I say, establishing the service management wrap and support team for the terminology service, which is a relatively new team for us in NHS Wales. And as Beck had already said, we're the first cloud hosted component using Docker containers. As I say, from my personal experience, it's been a really good challenging working environment, but I've really enjoyed learning everything. And you know, the support we've had from Syra has been amazing, and obviously working with NHS Digital on the proof of concept, we've learned so much. So that's B, really. Any questions?
Thanks, Tracy. Are there any questions from anyone? It's really nice here, sort of the hands-on experience, isn't it, Kate?
Sorry to interrupt. Any idea of performance? Have you managed to get any feedback on or metrics around performance?
We have got some, but our current pilot is using our proof of concept server, so it's not running on our production server. So, but we haven't had any issues on our proof of concept server with the performance at all. But I can, drop me a message and I can look into it further and get back to you.
Thank you.
We've done quite a lot of load balancing and things as part of our testing and UAT. So it's had a lot of pen testing and all sorts of people trying to break it in our cybersecurity teams. It's quite rigorous to get anything through into production. So yeah, we've been quite transparent. We're really happy to share any information that we've done and testing and evaluation and things.
We also have vendors using it runtime as a clinical application. One of is a cloud-based primary care system here in Australia as well. And I'm not sure if the NHS Digital team or the DXC team might like to comment as well about the national server. For those who do want to ask some more questions, I know that Tracy and Dale and Becca are going to join Michael's breakout group around data entry and search. So that's a really great opportunity to probably ask some more questions if that's something that you're really interested in that breakout group that will be happening in a little bit as well.
I can throw something quickly in there as well about performance. One thing to keep in mind in the implementation, which I'm sure Dougal or others could speak to as well, is that particularly in that runtime, largely read-only use case, OntoServer plays really nice with using standard web technologies with web caches, and you actually find a lot of the time that while there's a vast array of content in there, there's a lot of content that gets hit regularly. So just a simple web cache in front of it can give you a massive boost and works really well. And OntoServer sort of can be used with e-tags to revalidate the caching, or you can be more aggressive if you're not changing content behind it.
Yeah, we had a few conversations, didn't we, Trace, about caching, particularly for recording allergies and intolerances in the care record, because that essentially is a call that is going to be happening all the time. It's going to hit our clinical portal, will be hitting that. So we've looked at caching services as well to try and negate some of those issues. But just to say, I suppose, just to end with, I think we'll share the principles and guidelines that we develop, because actually what you see all this great stuff about what the terminology server can do, and you see the end product, but what you don't see is all of the hard yards that go in between. So people perceive that you just got this thing and you can plug in and play and it's great. You do have to get into the weeds on it. You do have to have the arguments about whether a clinician should climb hierarchies and trees in the UI, and whether you should store different, the concept IDs and the description IDs. So that I think was a massive achievement for us, was we were trying to agree that as we were working it through, so that's set in stone now. Any system that wants to come and talk to the terminology server has to adhere to those, which is great. But I'll finish there. I'm taking up too much time as usual talking. We'll be in the other session.
Thanks so much, Becca, Tracy, and I know Dale's on, who also was actively involved in the work. We've loved working with you guys, and I think it's a fantastic example of what can be achieved. I did see Charles taking photos of some of the screens, so I'm pretty sure Charles liked some of those principles, and probably speaking as a CCIO has lots of comments to make, and I know he's fully supportive of the role of SNOMED as an interface terminology as well. So Charles, I don't know if you want to comment now or save it for when you're presenting later, but I'm sure you've got some thoughts.
Well, other than just saying yes and then saying yes again, I think absolutely. The journey's been set. There's some terrific examples there. As you probably know, a long time ago now, I was a hematologist, so it's good to see myeloma taking the lead in Wales. A fascinating disease, and one that is crucifyingly horrible for the patient who experiences it. So collecting data and using that data to improve care is a fantastically great goal.
Thanks, Charles. So over to another excellent presentation. I know Richard's actively been involved for a number of years in INTEROPen events and presented recently. So we did ask Richard to give a presentation around his work with FAR terminology services. So over to you, Richard.
Okay, perfect. So hello. So I just wanted a quick comment on Rebecca's sort of closing remarks from that last one is, and I didn't cover it in my presentation, is from my experience today, implementing a terminology server within an organization, it's not a technology project, it's a business change project. And technology is just one small part of it. So if anyone thinks it's just like installing a technical thing in a cloud instance somewhere, it's not. It's far more far-reaching than that. Anyway, so cracking on. So a little bit about me. So yeah, I'm Richard Kavanagh. So I'm the lead data architect at GraphNet. I've been working in sort of this space of INTEROPen for many years. I've spent a long time working with Fire now. Prior to that, HL7 version 3, CDA version 2, Edifact, so on and so forth. So really spent probably last 15 years, unfortunately, now doing all this kind of stuff, and have seen kind of the evolution of terminology coming to the forefront of INTEROPen and exchanging clinical data. So I currently work in, as I say, for GraphNet, which is a supplier organization here in England. And prior to that, I spent about 13 years working in NHS in a number of interop related roles. So I will declare myself as knowledgeable in interoperability and data architectures. I'm not a terminologist, though in the last 2 years, I have worked an awful lot about terminology, more than I thought was possible. So a little bit about GraphNet, just to give a bit of context. So GraphNet is primarily a shared care record provider. I should say the market leading shared care record provider in England, and currently covers in excess of 20, somewhere between 20 and 25 million patients at the moment. And so we have a lot of data. We deal a lot of clinical data. Historically, that data was not ours; it was our customers' data, and they kind of put it into the shared care record. But increasingly, we're capturing more and more data ourselves on behalf of our customers. So there's kind of a mixed economy there. We also run public personal health records and do population health analytics and all that kind of stuff. And the data that we cover is broad, and it's pretty much anything that's out there. So primary care, acute, social care, community, so on and so forth. So we're having to deal with lots of different data, lots of different systems, lots of different interfaces, and lots of different systems at varying degrees of digital maturity and terminology maturity. So it's a complex arena that we're trying to introduce terminology services into. We've been looking at onto a server for, I say 12 months now, it's probably more than 12 months actually. And, been working out how we can gracefully introduce it into our systems as we kind of go through technology refreshes, and then also some tactical deployments to kind of give us some quick wins. So what I'm going to do today is kind of go through a couple of use cases where we've been working with Terminology Server, things that we set out to do, how successful they've been. Some of them are still, in development, still going on, but more importantly, some of the things that we found along the way, which, to be honest, we didn't anticipate initially on, and some of that some of that was maybe our naivety. Some of those who are more used to working with SNOMED will maybe go, yeah, of course you're going to find that, Richard. But it was a journey for us. So I thought we would just kind of share some of this today. So our first use case is round about primary care. So we within GraphNet take data in from all 4 of the primary care suppliers within England, and each of the primary care suppliers send data to us in different formats, of course. They're all proprietary formats, and we have to kind of handle that and bring it together. So what we wanted to do is take that data in and move to an ability to process SNOMED and process that data using SNOMED. So those of you who know about GP data will know that historically they used to use either read codes or CTV3 codes, and as much as primary care has largely moved to using SNOMED natively now, it's not to say all the systems have, so there's still the tail end of legacy code out there in primary care land, and it's how we deal with those. So the first challenge we got, and I'm not going to name and shame any of the primary care providers, is that one of the providers in their data sent to us all the SNOMED code with SNOMED description IDs in there, not SNOMED concept codes, which was interesting because onto a server, ETL, ECL, sorry, all works on concept codes. So our first challenge was to say, well, how do we go from a description ID to a concept code? And that's actually something which natively onto a server doesn't do. Now, we do have other terminology servers within our wider sort of alliance within GraphNet. So we're having to use that as an intermediary step before we can even get to the point where we can start doing some more clever work with those. The next thing that we found out is that as much as all the primary care suppliers do send us some form of SNOMED code, not all SNOMED is equal. So some of the suppliers have actually declared their own SNOMED namespace and provide SNOMED codes in their own namespace in that interface. Now, that's a perfectly legitimate thing to do within the land of SNOMED, but unfortunately for us, they don't actually publish any information about those. So as much as we get a code and we get a term, we get no relationship data whatsoever about those codes. So as far as those codes go, they're kind of just opaque to us, and there's not much we can do with them. Excuse me. So that's the challenge that we're having to work with. We get the obvious thing that people with SNOMED have to deal with, and that's the use of the receipt of inactive codes. The primary care data goes back typically quite some time for some patients, and the codes are recorded at the point care was given. So there's a growing population of inactive codes. Because the GP suppliers don't change the codes. So as SNOMED evolves and moves on, it leaves a trail behind it of these inactive codes, which we also have to deal with. In the world, certainly with England, I'm not sure if it applies to Wales, but perhaps it does. Then we had the issue of the terminology mappings from the legacy read CTV3 codes to SNOMED. And at the moment, the primary care organization does that. But later in the day, in that whole process of migration, there was a secondary set of SNOMED mappings came along, known as divert mappings, for handling observables in a more reliable way. And these seem to have been implemented somewhat patchily by the primary care providers, and the scope of where divert mappings exist also doesn't seem to be, for the purpose that they were created, doesn't seem to be holistic enough. So there are other places where I would argue it should have been applied, but of course the door's shut on that now, so it's up to us to see how we can manage that. And then we have sort of what we call I'm calling classifications, and not classifications as in OPCS or things like that, but classifications of how data is grouped together. So some of the GP suppliers will send us in their data. Here's all the immunization data. But the problem is what they call immunization data and what we call immunization data isn't necessarily the same thing. And that's kind of the first example where we kind of moved on to using SNOMED more and onto server more, is to deconstruct now some of the data that's coming, which is categorized in broad categories by the primary care organization, but we wanted it in someone different. So for example, when we got immunization data, so when we got data in, it was already tagged as this data is an immunization, but it wasn't always an immunization. So sometimes it was an immunization and an immunization procedure. Sometimes it was that the patient had consented for an immunization. Sometimes it was the guardian had consented for the individual, namely if it was a child. Sometimes it was the communication that a reminder had gone out for an immunization or advice for an immunization had gone out. So we, in our internal data architecture, had to deconstruct that. Now, handily, they all had codes, so we could use the, construct some value sets and some ECL statements that allowed us to decompose that. And that was very useful to us because actually, the way that the data comes in, it's quite predictable, and it allows us to use the power of SNOMED and the ontologies of SNOMED to kind of make sense of that. Now, there is a bit of a gotcha because we also had to accommodate all the things we just mentioned before, all the different local codes and all that kind of stuff, because as much as most of it was in UK edition SNOMED, some of it was in proprietary, local namespace SNOMED, and we had to tolerate both of those. And then we had data coming in, which was observations. Now, within the GP supply, they tag some data as being allergies and some data as being observations, but they're not always consistent. So all the allergies were indeed allergies, and we could validate that because we could validate it across the SNOMED ontology. But some of the observations were actually allergies, and they just how the data was captured, I'm presuming. So sometimes they weren't capturing things with the degree of precision that we needed. But of course we can intercept that now, because as observations come through, we can say, is it actually an observation? Is it an allergy? And then we can go further than that, because all the observations that came in were not truly observations in SNOMED language or even in FHIR language. Some of them were findings, some of them were procedures. So we can now deconstruct those as well. Using the properties of SNOMED, it's allowed us to do quite a lot more work to land this data into our own internal data architecture. So we created a set of value sets to do this, and then we can sort of validate codes being within certain value sets as we go along, and it's been very, very useful to us. So one of the things that it enters, and we'll touch on this a bit briefly on, is what I call terminology provenance. So we're very aware of data provenance within our world, because we get a lot of data from lots of different places, and we always want to know where the data came from, how it was loaded, so on and so forth, so we can trace the provenance of that data. But now we're having to consider terminology provenance, which is basically who assigned the code. So if a supplier sends a SNOMED code in, that's great, we need to know that. If they send a different code in and we map it to SNOMED, then we need to know that. We have to understand the whole sort of the provenance of a terminology, not just the data now. And that's just useful for us, so that if there's ever a dispute or whether anything happens, then we have that traceability. Okay, so moving on, our second use case is we have a capability within our systems for to receive messaging in, and then we have certain subsystems that can subscribe to messages come in and do sort of subsequent processing on that. And it's a fairly new system that we have. We have things like, for example, we may have a discharge summary get posted into us, and then on receipt of a discharge summary, we may want to do various things. But the challenge is, how do you know it's a discharge summary? There's all sorts of documents that come through. How do we know which ones are discharge summaries? Now, we've been fairly successful in working with our partners to go through and say, can you use the SNOMED code, please, as the coding scheme? And they were broadly receptive of that. And there's prior art within the UK edition of SNOMED to have document codes in there using SNOMED. So that was all readily available. The problem we have is some of the subscriptions were broader than just a single document type. And then it's how do we manage all those? So in the years gone by, we'd have had to have multiple subscriptions, one in each code. But now, of course, what we can do is we can just create a value set of all the codes of interest. And then as the subscriptions coming in, we can do work to say, actually, depending on whether the code is in value set A, B, or C, then take subsequent processing actions on there. Now, one of the challenges, of course, is that within SNOMED CT, there is no document ontology. There's just a flat list of documents. So we're having to do some work to work around that. And I did hear a disturbing bit of news, or gossip, should I say, recently where, and this may not be accurate, but there was some work going on centrally to perhaps not use SNOMED for document codes, which would be a bit of a shame. Yeah, so that one's working quite well, but we haven't actually deployed this system yet. No, we're in sort of testing with some of our partners on this, but it looks like it's going to be a useful way of using terminology and quite an easy thing to implement. And then, of course, the thing with all of these is you get into a point where you can change behaviors of the system through configuration, not code, which is kind of one of our mantras is, is to build everything which is, can be changed through configuration, not code. And changing value sets to include more documents in, less documents in is quite a quick thing to do. So the next one, which is data queries, and this was quite a complex area for us. So within GraphNet, clearly, we've been going for some time, and we've got some legacy systems, and we've got things which work the way they do, and we don't want to necessarily disrupt that. And as much as we're building new products and new services going forward, we're quite clear in our own minds that as much as we might put all the funky stuff in the new world, we don't want to disrupt the old world. So we have to build APIs that are very functionally rich and are very accommodating of different ways of querying data. So historically, prior to SNOMED being rolled out across the estate, typically our APIs would return data in what I would call categories of data. So you may make an API call on, I don't know, say, give me all pregnancy information. And the APIs we have today will do that. But that pregnancy information will be a mixture of procedures and observations and findings and all sorts of different things pertaining to pregnancy. So these span across different hierarchies within SNOMED, and then certainly when it comes to Fire APIs, span across different resource types in Fire. So we're having to work out how we deal with this, not just in a semantic way, but in a way which is highly performant, because we get a lot of API calls. So we spent a lot of time working through this, and and how we create a dual way of data, because all our data goes into one set of data repositories, but it's how we can access that data in a more clumpy, classification with a little c kind of manner, but also in a more semantically precise manner, using SNOMED and hierarchies and such. So to do this, we have a number of different approaches, and to be fair, some of them are a bit experimental, because as well as being able to accommodate those different type of access paths, we also have to tolerate data that has no codes at all. So it's not uncommon for us to receive, I don't know, medication data with no codes or allergy data with no codes, but we'll know it's a medication and we'll know it's an allergy, but we can't assign a code to it. We do lots of different things about attaching various metadata items to code when they came in, and so we have sort of lots of enrichment processes that will harvest metadata and attach it to records, mainly for the fulfillment of queries later down the line. And this is an area, and so we're definitely not finished on this, and it's a journey we're going to go through, and we will have to adapt as we go along. There's a bit of a challenge, thinking that we're going through as to where metadata resides, because we don't want to take too much metadata out of SNOMED, because if we take the metadata out of SNOMED and put it into the actual record, then SNOMED reorganizes or changes, but how do we reflect that back into the records? But we want to make it performant. So there's lots of trade-offs and discussions that we're kind of going through internally as to how to work this through. So we do harvest metadata. We take it through as we're loading data in, and we can look up SNOMED codes, harvest data out of there. There's work we're doing, which I happened to join one of the SNOMED International, the joint file SNOMED International calls recently, when they were talking about the semantic tags within SNOMED, and we are playing around with those at the moment, and I pricked my ears up when they were saying, well, they're not wholly reliable across the scope of SNOMED, and so I think we're okay for what we're using it in, but we're going to have to take a closer look at that. And then the other thing that we're doing is, we're getting to the point where we will have APIs. So we'll have APIs that we use internally. We're using value sets to surface those. We'll have APIs that we offer externally to our customers, and there'll be value sets in those, and how we manage those. So the management of terminology assets is kind of becoming a big deal for us, and how we manage them through the life cycle and provide governance processes and testing them, and testing them for semantic correctness, but also for performance. So there's all sorts of different features that we didn't necessarily think we would need to do when we set off. And then the last use case we kind of go through is, I guess an obvious one, is data validation. And now for data validation, we have to be quite accepting of the different levels of data that exist out in the NHS. So broadly it falls into sort of two camps, I guess. Three camps maybe. So first is NHS organisations or social care organisations who send data to us. So they've captured the data. Sometimes it's historical data, sometimes it's a daily or real-time feed coming through. But the issue is the data is already captured. It's not the data capture system that's sending us the data, it's kind of downstream from that. So there's really no ability to change that data. There's no ability to directly impact invalid codes or whatever at that point. So we have to accept that data into our system, because clinically that's what was recorded. But we are doing work where we can now provide data quality metrics and feedback to the data suppliers, because sometimes they don't know that the data is not particularly accurate, because they may not have the maturity in their system to do that. But we can now go back and say, do you know that you're recording allergy codes that are not allergies, or procedures that are not procedures? And that's kind of an evolving piece of work that we're doing. So there's always a bit of a trade-off. But then on the other side, we have systems where we have, third-party systems, maybe mobile apps or whatever, directly interfacing to us through our public APIs. And those we are more strict on, because actually it is the data capture systems that are interfacing directly to us. So we do ramp up the data quality bar on those and say, no, you're not putting an observation resource into our system without with a procedure code in it, or you're not putting a allergy resource into our system with an invalid code into it, and we can push back on those. And then we have our own internal data capture systems, increasingly, and then we're getting an explosion of those coming in, where once again we can offer better value by interfacing to the terminology servers, and making sure that we have that kind of semantic robustness going on. So that was a very, very rapid chat as we went through that, and I'll be at the session later on, and if people want to sort of ask more questions about that, I'm happy to go through those. So, but our challenge is not over, because they were just 4 use cases. We've got many, many others ongoing. But there's some kind of things that are kind of cross-cutting across all the different ways that we're using terminology, and this is where it gets it's beyond the terminology server being a tool. It's a tool, and that's not to diminish its value, but that's all it is. It's a tool, but it has to fit into a wider process. And the first one obviously is the pervasiveness for SNOMED. We're getting SNOMED out of primary care systems, and we are beginning to see it increasingly appear in other parts of the health landscape, but it's by no means pervasive. And it's really what's going to drive that up, as a point of, to the point where you could depend on it. And I don't know the answer to that. It does seem to have increased recently, but there's a long way for it to go. And then the second one, I guess it's the same with any kind of data capture. It's about data quality. We do see from different sources where terminology data will come in, and it will even have SNOMED in it, but the SNOMED is definitely not correct. So we have dialogue with those, but a lot of the time the data is captured. The clinical system doesn't have the ability to go and change it. It is what it is, and we have to tolerate that. We have to put strategies in place of how we can deal with different levels of comfort as to how well the codes are. And then it comes about trust, and especially when we get into more complicated ECL expressions, and we're not just relying on the ontology and the hierarchies and sub-hierarchies within SNOMED, but the different additional attributes within SNOMED, is how well are they populated within SNOMED? The fact that something doesn't have an attribute, is it because it just hasn't been put into SNOMED, or because that concept doesn't have that attribute? And we're kind of experimented on that, and that's a bit of, to be honest, our ignorance and lack of understanding of SNOMED. So we're working hard to upgrade on that. Maintenance. Maintenance is an ongoing concern. Clearly terminology, SNOMED is, it doesn't just get published once. And we're working on our strategies as to how we update that, so we will be looking to use a syndication service from NHS Digital, and that will be a good service. But we also have to deal with various local codes now, especially from the primary care suppliers. And each of those have their own local codes. Some of them are quite good at managing them, some of them are shockingly bad at managing them. But we have to build those into the mix. And because of that, we're going to have to make sure that we're maintaining our value sets, and so that they're taking those into account, either to accommodate the changing nature of SNOMED as it goes along, or the inclusion of new local codes. But essentially, this is not a do once and forget kind of operation. And it becomes a ongoing concern. And it's one of those things we've had a few chats with some of our colleagues and some of our clients and partners to go through and say, this isn't something which we think should be done by an organization. This is where we're kind of thinking there should be some community effort here, mainly because it's hard work, it's a lot of effort, and it doesn't really make sense, as much as we could say, so, no, if we did it, it'd benefit our systems. But our sort of mantra at the moment is the more that we share the terminology assets and the more we're open with it, but the more our customers will use it and the better stuff we will get coming in. So it's kind of a community effort, I believe. So the other side of the evolving of it is how we manage the governance of it, so test value sets and comparing value sets and stuff. And so we're doing a little bit of work on proof of concepts and how we do that. And mainly that was how we can build our own systems to use the 5 APAs interacting with a terminology server to have some kind of maintenance thing. So there's a little link on there, which was kind of our first generation proof of concept. The public offering is a little bit behind the times now, but we'll be doing some more work on that in the near term. And then once again, I talk about provenance, so who assigned the codes? If we're assigning codes, we're mapping codes, we're transforming codes, or then where do those codes come from? What concept maps or what were in use at that point in time, just for audit and accountability and stuff like that. And that was it. That was very rapid. I appreciate we kind of went through a few things. So I'll be on the session later on. And some contact details there if anyone wants to ask me any questions that come to mind afterwards. And as Michael mentioned earlier, there's always the Zulip channel as well, or the INTEROPen River. There's a wealth of different places to sort of reach out and ask questions. Okay, thank you.
Thanks, Richard. I loved what you were saying about working in the community, and it's about working together, because that's just a reminder to everyone that this is a pre-hack event. So today's efforts and learning is all about getting you all prepared to take part in our hackathon, which is happening at the end of February. And I'll be posting the link again for tickets to that, because the hackathons really do accelerate progress. They really do get everybody together in the right room and working together on the projects. And so it'd be great to see you all there and get your teams involved as well. Kate, I'll hand over to you.
Thanks, Helen. Thanks so much, Richard, for that presentation. Any really quick questions for Richard, or he definitely will be in the session after to be able to go through detail then? I think they're all holding off Richard for the actual breakout session. So last but not least, in the kind of the 3 presentations of implementation, I'd like to invite Charles to give his presentation around the work that he and Sophie, who I also know is on the call, and the work that you're looking at using SNOMED to support analytics. So Charles, over to you.
Sorry, Richard, could you just stop sharing your screen so Charles can, please?
It says I have stopped. It's offering me to share again.
Okay, I'm not sure. I'm still seeing your screen, Richard, but...
Shall I try?
Yeah, try and see what happens.
So, it tells me I'm going to stop somebody else's screen sharing. So I'll continue.
There we go. Try now.
Okay.
Perfect. Thanks. Oh, could you put it on present? Yeah, thanks.
Hello everyone. My name's Charles Oughtibridge. I'm the CCIO at Barts Health. As you heard before, I am a retired hematologist. I've been in the health IT space for some years now, really since as a rather naive medical director, I was in charge of implementing Cerner's EHR as part of the National Programme for IT at Barts Health in 2008. I guess my perspective on all of this is very different to the other presentations we've had this morning. And I come at it inevitably from the clinician's end and hope that we meet somewhere in the middle. The reason, obviously, for doing any of this is that people get sick and want to get better. And they want to do that as efficiently and as kindly and as well as we possibly can. And I think there is some real magic in what we all do here. And some of it you heard actually from the Welsh presentation, and then some really great ideas from the other presenters. But what I've tried to do is to boil down a key question in medicine that I think everybody wants to find answers to, and which I think everybody this morning has spoken to. And so the core health query is often, can I find a specific data item or data items related to a particular cohort of people and reference my group there to a pre-existing data set? And I've got some specific examples, the kind of things that Sophie and I are interested. So here's one which I think is of interest to any oncologist and any patient who has cancer. And so this query says, there is something about cancer which is genetically determined, either as a new mutation or actually is in the code base that we inherit. Those genes are really important. And if they do mutate, can I link the mutation to a SNOMED term for, let us say, lung cancer, but it could be any cancer, and then reference that to the kind of databases that big pharmacology organizations have to show all the known compounds that modulate those genes. In other words, interrupt an enzymatic pathway or things that growth factors that switch cells on, or interrupt coding performed by genes and their products. And here's an example of a really great little tool that was developed at the Boston group of hospitals to help clinicians in the front line, which just simply shows, according to the patient they're seeing, their cancer diagnosis and the mutations that have been observed in the sample, and with some clues as you work through this as to which specific treatment might be of high value to that patient. And now that degree of precision and personalized care, personalized treatment for patients with cancer is becoming standard, at least in all wealthy countries that can afford the drugs that have been developed at that level. Here's another example, which is something that Sophie and I are particularly interested in, and where we have a developing project. But it essentially tries to answer the question, which is, do patients with any kind of diabetes can develop foot disease? Foot disease is a pretty horrifying thing to have. You develop an ulcer, then often osteomyelitis in the bones of the foot, leading to a fairly inexorable process of amputation of the limb, and often a very marked shortening of your life. And so our question here is, can we find all the patients with a diabetic foot disease from, let us say, a type 2 diabetes cohort? And here is not reference to the data necessarily that's in our, the structured data in our electronic health record, but to give our clinicians a bit of latitude and say, we know your preference when you're recording many of the aspects of a patient's social details is that you like to use free text. And so can we interpret the natural language that the clinicians are using, translate that into post-coordinated SNOMED expressions and then link it to the diabetic foot disease. We're at the start of this project, but Sophie's already done some analysis, which is displayed in this graph here. So these are the patients with diabetes foot disease and obviously diabetes, and on the left-hand side are the features that have been taken out from an examination of the record and just listed using a machine learning algorithm in terms of importance of the feature. In this particular case, we see that age is probably the strongest determinant, as it often is, but there are lots of other things for us to explore, and where intervention might be very, very valuable for the patient's care in the long term if one manages to intervene early enough. And then my final specific query is one that is, I think, occupying all our minds at the moment, which is, why do some people get very severe COVID-19 infections? And so there's a current study led by a group, which I'll show you in a moment, but where whole genome sequencing of each patient with severe disease compared to those with less severe disease appears to show some targets within the genetic clusters that we all have, which may be important for either the identification and protection of susceptible individuals or the treatment of those people if they do get COVID-19. And here's a publication that came out in Nature Reviews just, I think, 2 weeks ago, showing the output of the genomic study, where the whole genome sequencing is being done in Edinburgh, but all hospitals contributing to NIHR research efforts are contributing patient samples. None of this is possible unless you have an electronic health record where people are recording data. So here's a very simple screen grab from a record of a patient with adenocarcinoma of the lung, which shows a number of key SNOMED descriptions. And obviously lying behind all of that is the data in coded terms, both description IDs and concept IDs that you would need for the computation, and a procedure history, which is pretty crucial to understanding what happened to that individual and what to pull out for analytical terms. My next slide, I'm not going to spend any time on, but you guys, those of you at least who are on the technical side, build these things. And I hardly know where I fit on this, but I know that at the output here are sources of data which I can query and turn into new treatments and new ways of thinking about patients. This is the data warehouse at Barts Health. It's a thing of beauty. It takes flows of data from many different systems illustrated on the outside of the diagram, with our core databases in the middle, and the outputs coming out at either real time or as updates, depending on the need and urgency for that data. These things don't exist in every secondary care system. And it's an area of work where we need, I think, to develop greater knowledge and also help those building data warehouses to understand how terminology servers work, how they can feed into a data warehouse, and also a great deal of learning around terminology servers. So the data analytics challenge, as I say, is really about the data of the individual, and for the benefit of the individual. And often, though, the question is, how did this person do in relation to the rest of the population? And can we make inferences for their care from examining the intersection of that individual data with the population data? And this morning's thing is about the tools that we need for that. And I think everybody this morning has said, yes, we need data in a common form. It really accelerates things if we can do automated analysis using standard methods. And it isn't just about one terminology. You need data from novel and varied sources. And I think throughout this, maybe one of the things we haven't talked very much about is you need ordinary people to comment and think about the data that they provide to people like us. So involving ordinary citizens in this process is very crucial to making safe analytics that people can understand. We do, I think, all agree again that we need a machine readable language for health, but trying to get over to ordinary people what ontological description of the content of health and care records means is hard. It's hard enough for me and you, but it's really hard for ordinary people. And trying to take us all along that journey to understand why it is safe to use data in this way is one of the challenges of our age, I think. So here are some next steps in applying that language. We need a grammar, and the grammar is of the subject, predicate, object, triple form, because that allows you to build the kind of databases that do this fast and do it well. You need to have an underlying descriptive logic to do the analytics, and the terminology should probably be mainly made of atomic concepts. So I think underlying everything that's been said this morning, we've all accepted that we will probably use AL2. We may not have said so, but we do. We have said all morning that you need mapping between different data types. There have been at least hints that constraining expressions to get to the core of a value set or to a group of codes that we can compare to the codes in an electronic health records required. That I think the yellow brick road showed how important having query rules and ways of doing that is vital. And we've talked a lot about FHIR and how the container and messaging standards help us to message that around the place. So you're all aware, because that's what this morning is about, that NHS England and NHSD have agreed to put in a terminology server. I think somebody else already put up this slide of what that will consist of and what will be in there. As you all know, I think, as most of you know something about me, I'm focused on the SNOMED CT part of this, but I often get asked by colleagues why, for example, our electronic health record doesn't have HPO terms in it. And how could they map HPO to SNOMED CT or vice versa, or at least align those two data types? So for those interested in rare disease, coding into HPO is what they do. The terminology server provides us a way of doing that in a way that is considerably easier than anything else at the moment. So I'm going to finish with just 3 slides, which illustrate a question that some colleagues came to me about 3 weeks ago and said, hey, Guttridge, we've been using our PACS and RIS system, but we're losing patients. And this was a group of neuro radiologists doing interventional radiology for patients with stroke. And they simply said, in COVID times, because we're working at home and because we're not always in the hospital and we're not always connected to people, we're losing patients that we think we should have a grasp of. And I said, well, the place to start is to make sure that you're ordering procedures using structured data, and then we can query the database easily to find those procedures and then find the patients. You'll never remember the patient's name, so why don't you start to use structured data to find the patients that you're interested in. And so I showed them a very simple operation note where I obviously didn't perform the procedure, but where I did fluoroscopy, guided percutaneous transluminal stent-assisted coil embolization of a cerebral aneurysm, which is a SNOMED term. And I dotted that with some other non-coded data about the procedure. And characteristically, like penicillin, I can't spell difficult, and there are a number of other spelling mistakes in this thing. But the crucial thing is that I now have a tool for this. And of course, they immediately perked up and said, "Hey, Doc, how will we find that group of procedure codes and be able to research them and track them in the long term?" So I introduced them to the public version of the ECL builder and said, "I'll take you through how you can do this. And your procedure has some definitions to it. The definition is you have to access the patient in a particular way. So let's see if there is an access code that helps you define your procedure." And indeed, there is an access relationship with a percutaneous approach. So let's put that catheter into somebody's arterial vein. And where are we heading for? Where's the procedure site going to be? It's up in the brain somewhere. So let's find the relationship with the procedure site direct and search for something inside the head. And there is indeed an intracranial vascular structure. And we're going to use a device in this case. And inevitably, there's a concept for embolization coil. If I run that relatively simple bit of ECL, I get this. I get 5 codes from which they can choose what they're doing. That, I think, opened a mindset which said, okay, I can get this. So I've got a group of codes which describe most of the things I do, and I can match those against the data in the trust data warehouse, which is all structured and relatively easy to examine, and then start to pull out other associated data from that patient's record, which is listed in different tables. And the window opens and off we go. And that's it from me. And if you want to learn more, I'm due to lead one of the next sessions.
Thanks, Charles. That's excellent. Thank you.
You want me to kick off?
Yeah, you're first on the list. Just
okay. Well, there are lots of reasons to join my group. First of all, I'm the nicest of the lot. Secondly, the analytics is the most thrilling, and you're going to get a practical demonstration of the use of the SNOMED International Browser and how you can use that for ECL queries. You're going to get a demonstration of the Onto server ECL machine as well, and how you can copy and paste from that to the international browser. And then I'm going to move into a little tool that one of the SNOMED developers has created to do a demonstration of the kind of analytics that you could do on a very large body of data. It's synthetic data as it happens, but if you had a big EHR data source, exactly the same tools could be applied. And I think it's pretty thrilling. At least I got thrilled by it.
Thank you, Charles. Sounds fantastic. Okay. Michael and Tracey, Michael, do you want to do your pitch? Oh, you're on mute, I think. I can't. It doesn't say you're on mute, but I can't hear you.
See, it's because Michael really won't participate in Charles's session.
Have another go, Michael. We still can't hear you.
I don't think Tracey's back yet. Tracey's battling. Tracy's toddler is in COVID isolation because of a case in the nursery. So yeah, she's battling mum and work life today.
Okay, Michael, we can't hear you. So Rebecca, do you want to do a quick pitch for your session? Because I imagine you'll be in there as well.
I'd love to, and I'm usually really good at winging it, but I don't know what Michael and Tracey are going to do in that session, but I'm sure it'll be absolutely fantastic.
Yeah, it sounds like there'll be a slight delay on Michael. Let's go to the next one. So Richard and Dion, I don't know who wants to, and
yeah, well, I was just going to say that, I mean, I would agree that Charles is the nicest, but we're actually the most interesting. So you're better off coming over to spend time with us. We're talking about interoperability, which without the interoperability, the analytics part's impossible anyway. So you're better off spending some time to figure out if you have those problems of dealing with the interoperability sorts of things that Richard was talking about, and a bunch of those challenges, where the terminology server can help with those sorts of challenges. Particularly what we'll probably spend a lot of time talking about is validation, translation, those kinds of services. But I'll go into some examples that show you how to use the terminology server to do that. And I think Richard can probably deep dive further into some of particularly the challenges from experience and how to deal with those. So yeah, we'll be not as nice, but we'll probably be more interesting.
And on behalf of Michael, he's left and I'm now admitting him back in. So if Charles is going to talk about how to use the data once you've got it, and Dion and Richard are going to talk about how to exchange the data, Michael's focusing on how do you actually get the data into your system and really focusing around the expand operations. And so unpacking a lot of the stuff around data entry, UI, how terminology services support it, and a really good chance to talk through that. I think Michael's probably going to look at the SNOMED UI demo, and Tracey and Becca and the team are going to be part of that as well. So great chance to ask those. So, you know, all of them are really lovely, but Charles is definitely the nicest, and I kind of think he's the most interesting too, but I didn't say
that. Wonderful. Okay, so thanks for that, Kate. I've opened the breakout rooms. But most of you, I'm going to have to put you in the water cooler first, because unfortunately Zoom has this weird thing about going in the water cooler, and then you should be able to see the list. If you go to the bottom of your screen, there should be an option for breakout rooms, and you should be able to see the list of options. Okay, so I'm just going to put something should pop up on your screen, and then I'll send you a warning before.
Really nice, and I think we all had a nice time, actually.
It was an excellent and fascinating session, Helen. It was really, really good, really good.
Excellent, excellent. Oh, that's what we like to hear. Michael, how did your session go? I hear you overcame the microphone issues.
Yes, fortunately overcame. I had to switch to different headset. We overcame the microphone issue. We ran out of time completely, but it was a terrifically interactive session, some really interesting questions. So I hope the people in the session got good value from it.
Wonderful, wonderful. And then the third session, how did that go? How did yours go, Richard or Dion?
It was good. I think we had quite a lot of discussion about various use cases that people are looking to use Terminology Server for, and we kind of elaborated a little bit about what Dion and I's experiences are. You caught us just short. We were halfway through a question when we got pulled back to the main room, so it's fine, you know. So we can either pick that up out of this session, or hold that thought until the actual terminology hack, whichever.
Well, there's both there, and there's River, of course. If anyone wants to ask any
Absolutely,
questions on River, use the Terminology Hackathon forum. That's what it's for. It's for these conversations. Feel free to set up topic threads. Maybe it might be good to just set one up for analytics, interoperability, and smart search, so you can sort of group those conversations together. And just use it as a space to share resources, etc. Because everybody now, I think, is hopefully looking forward to the hackathon and wanting to get ready to put all this learning into practice. Kate, if you want to pick up the wrap up and next steps and what people can do to keep this learning fresh until the hackathon.
Yeah, absolutely. Thanks so much, Helen, and thanks everyone for making this such an interactive session. It's so much easier to do this where everyone's engaged and asking lots of questions, particularly as it gets later into our evening. So really appreciate it. I think we have one final Menti question that we were going to put up if Dion is able to share it. So in the hackathon, there's a lot of kind of learning material that we presented this evening. And certainly I think the hackathon itself is going to be focused around emergency care, but interested from this group around what other additional sessions would you like to see included in the hack, whether they're learning sessions or focus, but also just feel free to put anything up around additional information that you want as well. So it should be open for you to be able to word cloud and put anything up that you desire. I don't know, Dion, whether you can actually see something happening on your screen, and we've got the same issue like last time where it's frozen for us.
Yeah, just while we're waiting for people to do that, I know there was a question early on that Andy was going to address about the framework. We said we were going to come back to. That's a 60-second thing that Andy can cover while we're waiting for people to put stuff up.
I can do very quickly. I mean, I won't speak to any screens, but I mean, just so that people are aware, I mean, the framework exists. And what we try to do is make that framework, whether we've been successful or not, time will tell, but to try and make that framework as accessible and as easy to use and for people and as seamless as possible. So I've banged my email again into the chat. So if anybody wants to follow up around that, then please do. We'd be very, very happy to organise additional calls and to give you a greater understanding of how that framework looks. But at a basic level, we've looked at it from a use case perspective, really. So to look at it, whether you're just wanting it to consume SNOMED and consume code, whether you're wanting to do authoring, whether you're wanting to use it for data entry, for analytics. So we've built a number of bundles, if you like, based around those use cases. So from a simple to a small to a medium to a large, I think probably NHSD would be really the only consumers of a large service, and that their service will be going live imminently. But do come and chat to us, and we'll talk through the use cases, how you want to use it, and start setting that up and getting you access. So it's very much a collaboration between ourselves as DXC as a kind of a host and service wrapper for all of this, working with Nicholas and Paul, etc., NHSD, and then obviously our wonderful colleagues at CSIRO. So yeah, be very happy to come and speak to you all about it.
Could I just add, sorry, I know we've touched upon various ways of collaborating before in conversations, but we do have a fixed meeting every Tuesday morning in the run up to the hackathon. So for the next 2 or 3 weeks, 2 weeks, we will have these Tuesday morning meetings. So if you do want to help steer the hackathon or have a better idea of what to expect or how to prepare, join us and help just sort of provide a bit of input and let us know what you're wanting to do and see and things at the hackathon and help shape it. We've only got a few meetings left, but I'll be sharing the details for that on the River forum again for anyone who wants the Zoom details for our Tuesday morning meeting. It starts at 8. for an hour
Good.
every Tuesday.
Just to add to what Andy was saying, I've also put in the URL for our services page, which has a bit more information on the framework as well. But yeah, Andy's the expert.
That's very kind of you to say, Paul. I'm not sure. I can certainly bring lots of experts to the table, but yeah, no, absolutely.
So thanks everyone for your input into this. I know that certainly all the sessions were recorded and will be made available, and all the information will be made available. So for those who want to hear what happened in Charles's session and Richard and Dion's session, then certainly, and Michael's, watch those. I know there's a bunch of links available. We do have a bunch of exemplars and postman scripts and plunkers and other things that people can interact with. And I know that a bunch of those links have been put in. Do really encourage people with the Fire Chat channel as well. And we're really happy for anyone to get in contact if they've got Onto server or Fire Terminology Server specific questions, and really looking forward to continuing to work with you over the few weeks and prepare for the hack and beyond. So thank you everyone, and thank you to Charles and Richard and Tracey and Becca for delivering fantastic presentations this evening as well, and supporting the breakout groups. It's great to have real life implementation experiences and people contribute to the discussion. So really appreciate everyone's time to do that.
Thanks, Kate.
Thank
you. Kate, do you have any homework for anyone before the... Is there anything that people can be doing before the hackathon in preparation, other than spreading the word and getting on Twitter and making sure we get all the main people involved who need to be there?
I think definitely spreading the word. I think from a Fire Terminology Services point of view, then certainly the links that have been provided by the team around that. And I think what we'll need to do out of the Tuesday call is anything specific in relation to the actual scenarios for the hack itself. We need to be able to start to share those with the people and who want to participate. But from a straight Fire Terminology Services API, there's certainly a bunch of material provided tonight for people to be able to get going with. Michael, Dion, anything in particular you'd want to point people to in terms of getting started?
I think, yeah, the Postman collection that John's just posted to the chat is a good place to start for examples that are templated that exercise most of the API.
Yeah, I'd agree, and probably the exemplars. I don't know if you ended up showing those, Michael, or if we should put those in the chat as well. I will put them in the chat right now if I can find it. I think that
for you.
Yeah, it might just be better if these were also shared on River in the forum, in the Terminology Server Learnathon and Hackathon forum, just so that it's there after the chat disappears, basically.
Yeah, so those are mostly for for developers to find out how to actually do specific things with the Fire API, and so yeah, should be really good for that.
Wonderful. Okay, well, I think that's everything for now, and we'll let our Australian colleagues go and get some sleep. Thank you everyone for your contributions and for taking part, and we look forward to seeing you in a few weeks for the hack proper. I hope everyone will be able to get involved, and we look forward to seeing you then. Thank you. Thanks, Kate. Thanks to all the session leads.
Thank you, Helen.
Charles, Michael, everyone.
Thanks for everything, Helen, for organising that. It was a really good session. Thank you.
Thanks, Helen.
Thank you.
Thank you, guys.
Yep. Thanks all.